Hi friends, good morning. Good morning Soumya. Soumya is there. What about the other guys? So one is me and other one is Soumya. Who is that other guy? Just a minute. If there is anyone, please comment. Only 3 people are watching. Please do like, share, subscribe. I kept another day for transportation as the heading, but it got a day for transportation too. Am I audible guys? Am I audible, visible? Please let me know. Am I audible, visible? If there is anyone, please do comment, then only I'll come to know whoever that is present over there, right? So if there is anyone, please comment. Soumya is there. Nice Soumya. Soumya, Karthik. 2 people are there. What about the other people? Naik. Good morning, sir. All clear. Vipul Naik. Good morning. Audible and visible. Nice to hear that. And sorry for the delay. I took 15 minutes delay. Yeah. I woke up late. That's the reason. So, what have you done yesterday night after the class? Good morning. Good morning. What have you done yesterday night after the class? What have you done? Have you solved any other any more questions, or have you solved any other chapter or any other subject? Have you read any subjects? Just wanted to ask, that's the reason. Maths, okay. So yeah, fine. Anyway, so things goes something like this. I have received a message yesterday. One student was saying that he is also a middle class guy. So there are many of middle class guys, and as I told you, I wanted to say this once again. Supreme Court said they are not going to postpone gate examination. So I want on that day only, I told you that you have to train your mind in such a way that whenever there is an examination, you have to write the examination. Why? Because uh, if these type of confusions will affect mainly middle class guys, not this poor and rich guys, middle class guys. Why? Because they feel like they will be constantly reading, and suddenly because of this postponement and all those things, they'll take that in their brain. They think that it will get postponed, or it won't they'll involve more into this, and finally it doesn't get postponed, and then they feel like I am depressed, and because of this I am not giving examination. Don't find the reasons guys. Okay, as I already said, whenever there is an examination, you have to give it in a proper manner. You should be ready for it. Okay, so there is no postponement, and it's okay, it's very well. Already you have prepared for February 12th. For past 1 year you are preparing for Feb 12th only, so you have to be very much clear in that way. Fine. I just wanted to say this because you have to be very much strong. Fine. Next, now yesterday we have seen introduction, we have seen geometric design of highways, we have seen traffic engineering. Now we'll be seeing highway pavements, design of pavements. In design of pavements, there are 2 types of pavements. First one is flexible pavement and rigid pavement. Flexible pavement and rigid pavement, right? Pradeep Kumar, yeah, it is available after the class. You just have to like right now. Once if you like this, I think if you go to YouTube after that, in your liked videos, it is available. Yeah, it is available. Why it is not available? It is available. You can see that, not a big issues. Fine. So let's see the MCQ and AT questions. It is not in a proper manner, but anyway, you can see this. A subgrade soil sample was tested using standard Cbr apparatus, and the observations are given below. Using standard Cbr apparatus, a subgrade soil sample was tested, and load at penetration of 2.5 mm load is 60.5 kgs, penetration of 5 mm load is 80.5 kgs. Assuming that load penetration curve is convex throughout, the CBR value of the sample is. So majority of questions in flexible pavement you see from CBR and modified CBR method only. So flexible pavements, generally what you will see in flexible pavements, soil subgrade, subbase course, base course and surface course. So this is soil subgrade, soil subgrade. That means generally that is the soil on which you are going to lay the pavement. This is subbase course, subbase course, base course, base course and surface course, surface course. Fine. So this is how flexible pavement looks like. Flexible pavement looks like. Flexible pavement looks like. So there are many methods to find out the thickness of the flexible pavement. Out of one, that method is CBR method, California bearing ratio method. CBR method, CBR method, California bearing ratio method, California bearing ratio method. Fine. So what is CBR? CBR, what is CBR? CBR is given as load carrying capacity, load carrying capacity of a sample, at 2.5 mm or 5 mm penetration, or 2.5 mm or 5 mm penetration upon load carrying capacity of, upon load carrying capacity of, load carrying capacity, load carrying capacity of standard aggregates, standard aggregates, standard aggregates at 2.5 mm or 5 mm penetration, at 2.5 mm or 5 mm penetration. Standard aggregates. Standard aggregates means generally the load carrying capacity at the aggregates, these values is fixed. For 2.5 mm penetration, standard load, 2.5 mm penetration, standard load, standard load, standard load is 1370 kgs. For 5 mm penetration, standard load is 2050 kgs. This is the standard load. Okay, this is penetration. Penetration. This is the standard load, and the load carrying capacity of the sample will be given to you. See, in a simplest way, if you want me to explain this test, how exactly it would be is, our major idea is to find out the thickness of the soil sample. Major idea is to find out the thickness of the soil sample. So this is the plunger, this is the plunger rod, this is the plunger rod, and this is soil sample, and these are aggregates. Fine. So load is being applied. Rate of application of loading, rate of loading equals to 1.25 mm for 5 minutes penetration. 5 minutes penetration. It varies actually for different thing. Anyway, fine. So you'll be keeping on applying the loading. Once if you apply the load at the load at which there is a penetration of 2.5 mm, the plunger has to penetrate by an amount of 2.5 mm, and plunger has to penetrate at to a depth of 5 mm. What is the load that is required for plunger to penetrate up to a depth of 5 mm? All those things will be noted, and then a curve is being drawn. Between the load and penetration. Load versus penetration curve is being drawn. Load versus penetration. Fine. Load versus penetration. Generally, it would be convex throughout. It has to be convex throughout, something like this, and load corresponding to 2.5 mm penetration and load corresponding to 5 mm penetration you will note down, and you will try to find out the Cbr value. Corresponding to 5 mm penetration, corresponding to 2.5 mm penetration, you will take the Cbr value accordingly. Fine. Let us say this is P1, this is P2. But in actual, the curve will not be perfectly convex. There will be concavity in the initial stages. Why, sir? Why there will be concavity in the initial stages? This concavity, it can be because of the soil sample and bottom portion of plunger and top portion of soil sample is not perfectly being horizontal. That can be one of the thing. Or if soil sample is very soft, then also it can initial concavity you will be seeing. These are the reasons for initial concavity. Fine. Generally, Cbr at 2.5 mm, should be more than Cbr at 5 mm. Cbr at 2.5 mm is greater than or equal to generally. It's not compulsory that this has to occur. Generally, this is the value. Fine. Okay. If you are not getting the thing, what you will be doing is you will be repeating the test, and finally whatever you get, you will take that. Fine. So Cbr of soil sample, or Cbr of any sample, equals to maximum of Cbr at 2.5 mm and Cbr at 5 mm. Okay, Cbr at 2.5 mm and Cbr at 5 mm. Maximum of these two things is considered as California bearing ratio. Fine. Generally, how you are going to find out thickness of the pavement? If you have done test for Cbr of soil subgrade, let us say if you have done the test of Cbr soil subgrade, it will give you the thickness. What is the thickness that should be provided above soil subgrade? Fine. Let us say you know the Cbr of soil subgrade, then thickness that should be provided is equals to under root of 1.75 p upon Cbr percentage minus p upon p pi, where p is the load and small p is the contact pressure or tire pressure, contact pressure or tire pressure, and this is pressure. So generally P equals to P multiplied with area. Area is pi a square. So a square would be equals to P upon P pi, where a is the radius of contact area. Fine. So this value would be under root of 1.75 p upon Cbr percentage, fine, minus a square also you can write. Okay, here if Cbr of soil subgrade you are using, it will give you the thickness that should be provided, thickness of the this whole thickness it will give. If you are using for sub base, this whole thickness it will give, fine, it will give something like this. And major disadvantage from this method is, it will not consider the type of material that you are providing. That means you have done Cbr of soil subgrade, you got some 50 centimeters thickness. Okay, even though if you use clay it would be 50 centimeters only, if you use marble it will be 50 centimeters only, if you use granite then also it will be saying 50 centimeters only. That means it will not consider the type of the material that is being used. Whatever the material you use, the same amount of thickness you have to provide. That is the major disadvantage from this method. It will not consider the type of the material that is going to be used. This is the idea. You have to remember major points is these things. Fine. Anyway, what is the question that is being asked? Cbr, the load at 2.5 mm penetration is 60.5 kgs, load at 5 mm penetration is 80.5 kgs. What is the Cbr value of soil sample? So how you are going to find out? Cbr value of soil sample would be equals to maximum of Cbr at 2.5 mm penetration and Cbr at 5 mm penetration. So this would be equals to 60.5 upon 1370 multiplied with 100, and this is equals to 80.5 upon 2050 multiplied with 100. So what is this value? Please let me know. Please let me know what are these values. Please do like, share, subscribe. Any doubts, guys? So 3.92 for 5 mm penetration and 4.41, 3.92 for 4.41 for 2.1 mm penetration and 3.92 for 5 mm penetration. 3.92 for 5 mm penetration. So finally the Cbr value, Cbr equals to 4.41 percentage. Cbr value is 4.41 percentage. Fine. Okay, so this is how you'll try to find out the Cbr value. 4.4, option is C. I hope you don't have any doubts from this. During a Cbr test, try to solve this question. During a Cbr test, the load sustained during a CBR test, the load sustained by remolded soil specimen at 5 mm penetration is 50 kgs. What is the CBR value? CBR at load sustained by soil specimen at 5 mm penetration is 50 kgs. What is the CBR value? Please give me the answer. Only 3 people are watching. It's okay. Fine, everyone. What is the answer? Please give me the answer, guys. D. So people are saying it as D. 2.4, option D. Fine. So how you are going to calculate 50 kgs? 50 upon 2050. Sir, he has not mentioned anything regarding 2.5 mm, then don't worry about it. CBR value equals to something like this. So 50 upon 205 into 100, 1 by 4. So approximately 2.4%. Option D. Fine. So this is one of the thing. Now, and then there is this method for designing of flexible pavements, that is group index method. Also you will be generally seeing group index method for designing of flexible pavements. Fine. So group index method for designing of flexible pavements, if we talk about it, generally group index method is based on index properties of the soil. You might have seen this in your soil mechanics also. Group index method, it is based on index properties of the soil, right? Based on index properties, based on index properties of soil, like liquid limit, plastic limit, sieve analysis, etc. Right? Sieve analysis, etc. Fine. So if this is the condition, generally group index is given as 0.2a, 0.01 BD plus 0.005 AC, right? 0.005 AC, where A is generally given as P minus 35 and it should not be greater than 40. B is given as P minus 15, it should not be greater than 40. C is given as liquid limit minus 40, it should not be more than 20. And D is given as plasticity index minus 10, it should not be more than 20. Fine. So where P is the percentage of particles passing through that 75 micron C, okay. And WL is the liquid limit of the soil sample, liquid limit of soil sample, and IP. IP equals to plasticity index. IP equals to plasticity index, that is liquid limit minus plastic limit. Okay, this is how you try to find out the group index. Higher is the group index, poorer is the quality of the soil, right? Higher is the group index and poorer is the quality of the soil. Okay, if group index is more, quality of soil is poor. If quality of soil is poor, then thickness that should be provided is more. Group index, quality of soil. Quality of soil. So what is group index? 0 to 1, 2 to 4, 5 to 9, 10 to 20. Good, fair, poor, very poor. Fine, very poor. Fine. So higher is the group index, poorer is the quality of the soil. If quality of soil is less, you have to provide more thickness. The disadvantage is same. Here also it will not consider the properties of the material. Whether you are using marble or you are using the clay, you will be providing same amount of thickness. That is group index method. Fine. And anyway, what is the question that is given to you? If group index of soil subgrade is 7, the soil subgrade is rated as, group index is 7. If it is 7, it would be in this range. So quality of soil is poor. Quality of soil is poor. Simple. Quality of soil is poor. This is how you will try to solve group index method. Next method in the flexible pavements, in design of flexible pavements, is modified Cbr method. One of the most, many times questions are being asked from here. Okay, modified Cbr method. Fine. So here what we'll try to find out is, there are many vehicles will be moving with different wheel loads. So instead of designing for different wheel loads, we'll be designing for standard axle load. Fine. Number of cumulative standard axles in an year. What we try to find out over here is number of cumulative standard axles in an year. Number of cumulative standard axles in an year is generally given as 365 multiplied with A multiplied with 1 plus R upon 100 whole to the power of n minus 1 upon R upon 100 multiplied with lane distribution factor, vehicle damage factor and load safety factor. Lane distribution factor, vehicle damage factor and load safety factor. Sir, what is that you are trying to say? See, there are different vehicles. There would be, there would be some bicycle going on, there would be car that is going on, there would be a huge truck that is going on, there would be army truck that would be going on. Fine. Different vehicles with different load carrying capacities will be moving on. So for which one you have to design? Fine. So there is a standard axle load. There is a standard axle load that we generally consider. Standard axle load that we generally consider is with a single axle and dual wheels on both the sides. With a single axle and dual wheel on both the sides. Single axle with dual wheel on both the sides. Fine. So the standard load for this one is 82 kilonewtons or 8.2 tons, or you can also say 8200 kgs. 8200 kgs. This is the standard axle load. Standard axle load. Generally this is what you will be considered. This is the standard axle load. So that means each wheel will be carrying a load of 2050 kgs. This will also be 2050 kgs. This is also 2050 kgs. Fine. Everything is, this is 2050 kgs and this is also 2050 kgs. This is the standard axle load. That means all the loads will be converted to this standard axle load. by this factors, there are different factors. Generally by vehicle damage factor you will be doing that. Fine. So what is a a is the number of commercial vehicles per day, number of commercial vehicles per day crossing the section or at the section by the end of construction, by the end of construction of road, by the end of construction of road. Fine. And r equals to rate of growth of traffic, rate of growth of traffic. Generally it would be in the range of 5 to 7% rate of growth of traffic. N is equals to design life of road, design life of road. N equals to design life of road. Fine. So number of commercial vehicles per day at the section by the end of construction of road. This is A. Generally sometimes A is also given as P multiplied with 1 plus R by 100 whole to the power of X, where P equals to last count of number of commercial vehicles per day, number of commercial vehicles per day before the construction of the road. Before the construction of the road, for construction of the road certain time period will be taking, that is X. Fine. Before the construction of road, before the construction of road, this is P. R equals to rate of growth of traffic, rate of growth of traffic, rate of growth of traffic. X equals to time period for construction of road, time period for construction of a road. Okay, so these are the points that you have to remember in modified CBR method. So here we are going to convert every commercial vehicle into something like this. See, the standard axles keeps on changing. If there is single axle with dual wheels on both the sides, this is the standard axle, standard load. If there is a single axle with single wheel on both the sides, single wheel on both the sides, the standard load is 68 kilonewtons, 6.8 tons. 68 kilonewtons or 6.8 tons, both will be same. At the same time, the standard load, if there is dual axle with dual wheels, dual axle with dual wheels on both the side. Fine. So here the standard load would be 148 kilonewtons. Standard load would be 148 kilonewtons. Fine. Next, if nothing is mentioned in the question, you'll be taking it as 8.2 tons only. If they are mentioning something in the question, then you have to take different values. Okay. If they are mentioning like 3 axles with dual wheels on the both side, 2 axle with dual wheels on both the side, or single axle with single wheels on the both the side, then it keeps on changing. But if nothing is mentioned, you will be taking the standard load as 8.2 tons only. Okay, this is one of the case. So here it is 3 axles with dual wheel on both the side, standard load would be 224 kilo newtons. Here it would be 224 kilo 224 kilo newtons. This is the standard load. Fine. So this is the standard load. This is 3 axles with dual wheels on the both sides, 2 axles with, this is called axle, and these are wheels. And this is single axle with dual wheel on both the sides. This is single axle with single wheels on both the sides. Fine. Oh, thank you, Praveen, for your kind words. Anyway, so these are the points that you have to generally see. Now, there is something called lane distribution factor, vehicle damage factor, and load safety factor. Load safety factor is same as that you will see in the RCC, that load factor that you will be using. Sometimes a huge amount of load comes. So the load, in order to overcome that, load safety factor will be given to you in the question only. Sometimes it will be given. If nothing is given, you will be taking this as 1. Lane distribution factor. So what exactly is the lane distribution factor is? In lane distribution factor, there are different carriageways you will be seeing. See, vehicles will be divided into different lanes. All the vehicles will not go only in a single lane. It will be divided into different lanes, right? So if there is a single carriageway, single carriageway, and if there is dual carriageway, if there is single carriageway and if there is dual carriageway, lane distribution factor for one lane road, if there is one lane, then LDF equals to 1. Here also, if there is one lane, then LDF equals to 1. If it is two lane, LDF equals to 0.75. Here also, if it is two lane, LDF equals to 0.75. Directly here we'll go for 4 lane load. 4 lane, LDF equals to 0.4. 3 lane, LDF equals to 0.6, and 4 lane LDF equals to 0.45. See what exactly is dual carriageway and single carriageway means. Here there will be a divider. Here there will be divider. Okay, there will be divider. If let us say vehicles are moving like this, vehicles are moving like this, vehicles are moving like this, vehicles are coming like this, vehicles are coming like this. So here this is 2 lane dual carriageway. 2 lane dual carriageway. Dual carriageway. And number of vehicles, if I am talking about N, is taken over here. Number of cumulative standard axles is taken from here only for one single lane. This is 2 lane, 1 lane, 2 lane dual carriageway. Fine. There is a divider. There is a divider. Divider is present. And if I say single carriageway, if I say single carriageway, then there won't be any dividers. 1, 2, 3, 4. So here this is 4 lane, 1 lane, 2 lane, 3 lane, 4 lane. 4 lane single carriageway. 4 lane single carriageway. No dividers. Fine. Single carriageway. See, if nothing is mentioned in the question, you have to remember this. If something they are mentioning in the question, then you don't have to remember this. Okay. This is one of the point. Next, vehicle damage factor, VDF. VDF is vehicle damage factor. This is the factor that is used to convert. Different commercial vehicles, cycle, scooter, car, bus, everything to a single standard axle. That is the vehicle damage factor. Generally, this is calculated by using a load factor called as equivalent axial load factor. Equivalent axial load factor. equivalent axial load factor, that is generally given as L upon Ls to the power of 4. Fourth power law. Fourth power law. Fourth power law. Where Ls is the standard load. L is the applied load. L is the applied load. Ls is the standard axial load. Standard axial load. If nothing is mentioned in the question, you'll take the standard axial load as 8.2 tons, 82 kilonewtons, or 8,200 kgs. If they mention that you have to use single axle, that means if they mention this, then equivalent axial load factor would be equals to L upon 224 to the power of 4. Here equivalent axial load factor equals to L upon 148 to the power of 4, and here equivalent axial load factor would be equals to L upon 68 to the power of 4, and here equivalent axial load factor would be equals to, if it is in kilonewtons, I am telling these values. If it is in newtons, substitute that in newtons. This is equivalent axial load factor. By multiplying this with the number of repetitions, you will get your answer. Okay, that is a vehicle damage factor, and load safety factor anyway we are seeing. So number of cumulative standard axles in an year, or cumulative standard axle repetitions in an year. Repetitions in an year, N. So we are going to find out cumulative standard axles. Once you find out cumulative standard axles, if standard axles is very much high, then what you will be doing, you will be providing more thickness. If it is less, then you will be providing less thickness. A table will be there. A table will be there between cumulative standard axle and thickness, right? A table will be there between the cumulative standard axles and thickness. Number of cumulative standard axles and thickness. Number of standard axles, standard axle, standard axial repetitions, standard axial repetitions, thickness. Fine, a table will be there. Based on the table, find out the number of cumulative standard axles N and corresponding thickness you can give in the examination. Okay, so any doubts in this, you can ask me. Any doubts? Any doubts? Please go ahead and ask me. Please do comment. Once if you comment, then only I can understand whether you are able to understand things or not. Please do comment. Please do like, share, subscribe. Fine. If you are not having any doubts, then try to solve this question. A two-lane single carriageway is to be designed for a design life period of 15 years. And total two-way traffic intensity in the year of completion of construction is expected to be 2000 commercial vehicles per day. Vehicle damage factor is 3. Lane distribution factor is 0.75. Assuming annual rate of growth of traffic as 7.5%, the design traffic expressed in cumulative number of standard axles is. So design life period, N is 15 years, and then A value at the end of the construction you can say that is 2000 commercial vehicles per day. Vehicle damage factor is 3. Lane distribution factor is 0.75. Annual rate of growth as 7.5%. Number of cumulative standard axles he is asking. Number of cumulative standard axles, right? So design life N equals to 15 years. Design life period N equals to 15 years, and A equals to 2000 commercial vehicles per day. Okay, next, vehicle damage factor equals to 3.0. Lane distribution factor equals to 0.75, and annual rate of growth R equals to 7.5%. that equals to 7.5 upon 100, whatever it is. You can use 7.5 only over there. Fine. And then what is the traffic that is expressed? N value. He is asking N value. So N equals to 365 multiplied with A multiplied with 1 plus R by 100 whole to the power of N minus 1 upon R by 100. That means R by 100 means you can directly use 7.5 over here multiplied with LDF, VDF and LSF. So this is equals to 365 multiplied with 2000 multiplied with 1 plus 7.5 upon 100 to the power of 15 minus 1 upon 7.5 upon 100 multiplied with LDF is 3, VDF is 0.75 and LSF nothing is mentioned, you will be taking that as 1. So what is this value? Please give me the answer. Please use the calci. Okay. Praveen Shankar, I think for structure analysis and steel structures already I have taken the quick revision, but that was in recorded versions. You can go through that. And structure analysis I think I have taken in the starting of the year, but anyway, if you want structure analysis, for structure analysis also I'll take, not a big issue. Steel already I have done, but once again if I do that it won't look good. Okay. What is the answer, guys? Today is 4th, so 5, 6, 7, 8, 9, 10, 11. 7 days. 7 days for your gate examination. Fine, not a big issue. Still there are 7 days. Till 11th you can do whatever you wanted to do. And by 12 you have to go calm and sit and give your examination in a better way possible. So please do like, share, subscribe and share with your friends as much as possible. Fine. So what is N value? Please tell me. As I said, this will not be that much useful for rich people. For poor and middle class who have not done transportation might be useful for you guys. Okay. For rich people already they might be feeling bored because they have already done these questions. I think Kumar is not there. That guy said he'll be there and he is not here. Nice. Fine. So what is the value of N? Please give me the answer. What is the value of N? fast calculation is also one of the important thing. Don't use scientific calculator. You have to use normal calculator and give me the answer as soon as possible. 1.075 to the first you have to start from here. 1.075 to the power of 15 minus 1 divided by, then multiply with everything, you'll get the answer. What is the answer, guys? Please give me the answer. Please give me the answer. See, don't ask me to do the calculations also. That is your part to do. That you have to do that. And at the same time, by the evening, please let me know what is the next subject that you want me to take. Please give me the answer, guys. Make it fast. What happened? Very much silent. What happened? It's too much of time. Is there any technical issues, network issues? Please give me the answer. Make it fast. What happened? Hello, hello. If there is someone, please comment, guys. Why you are taking this much amount of time? 35.7, I think, sir. You think, okay, in examination, what you'll, I think, is there any option like 35.7, I think? No. Sorry, Soumya, there is no option called 35.7, I think. It is not there. You have to give me the proper answer. Make it fast. Do the calculations. I am not going to do that. You are the one who is going to do that. Do the calculation. It is not 35.7, option is not there. Do the calculation properly. Three people are watching. See, I don't know that 9 people who are watching can solve this question and we can move to the another question, right? Forty-two point 89, that is 42.9 into 10 to the power of 6. So do the calculations properly and don't waste your time on this. You have to solve these questions. 42.9 into 10 to the power of 6. So if they ask in million standard axial, that means 10 to the power of 6, you will be removing 42.9 million standard axial. So that's it, Soumya. Please be very much cautious and you have to solve everything in a better way. Fine. This is one of the thing. Next, in the same lines, try to solve this question. IRC 37 1984. Now IRC 37 to for design of flexible pavement, just right now we will be using IRC 37 2018. IRC 37 2018. Anyway, number of commercial vehicles per day when construction is completed, A value is given to you, 2723 vehicles per day. Annual rate of growth of traffic, R value is 5%, and design life of the period N equals to 10 years. Vehicle damage factor is 2.4 and Cbr value for soil subgrade is 5%. Fine, that is given to you. VDF is given to you. LDF is not given. You will take that as 1. LSF is not given. You will take that as 1. Fine. So now number of cumulative standard axials and thickness of pavement is given to you. He is asking what is the thickness of pavement that you are going to provide. So first try to find out number of standard axials. For that, corresponding to that, you will get the thickness of the pavement. So number of standard axials, where you will get that from? You will get that from here. Fine. So this is the parameters that is given to you. Try to find out number of standard axials. Please try to do that. Number of standard axials. What is the answer, guys? If this is the case, first try to give me the answer. What is the value of n, number of cumulative standard axles? A value is known. This is A, R, N, VDF. So number of cumulative standard axles, please give me the answer. N equals to 365 multiplied with A value is 2723 vehicles per day. 2723 vehicles per day multiplied with 1 plus R value. What is the value of R? 5%. 5 upon 100 to the power of n. N is 10. 10 minus 1 upon 5 upon 100. 5 upon 100 multiplied with vehicle damage factor is 2.4. Lane distribution factor is 1. This is also 1. Simple calculation. Tell me what is the value of n. What is the value of n? So 30 MSA, 30 million standard axles you are getting. If it is 30 million standard axles means you will be getting 30 into 10 to the power of 6. So for 30 million standard axles, it is 670 mm. 30 million standard axles, it is 670 mm. Your option is C. Okay. So that is how you will try to solve these type of questions. Any doubts in this? Fine. If you are not having any doubts, sir, what is the usage of CBR value? There is no usage of CBR value here. That is just given to confuse you. That's it. Next. Next question is, the data given below pertain to the design of the flexible pavement. In initial traffic is 1213 CVPD. Traffic growth rate is 8% per annum. Design life is 12 years. Vehicle damage factor is 2.5. Lane distribution factor is 1. The design traffic in terms of million standard axle to be catered would be. What should be the design traffic in terms of million standard axle? So A value is given to you 1213 CVPD. A value is 1213 CVPD, and then traffic growth rate is 8%. Traffic growth rate is 8%. Traffic growth rate is 8%, and 12 years vehicle damage factor is 2.5. N is 12 years. Vehicle damage factor is 2.5. Vehicle damage factor is 2.5. Lane distribution factor is 1. Fine. And design traffic in terms of million standard axles to be catered would be. That's it. What is the design traffic in terms of million standard axle? Please give me the answer. What is the design standard axles? Design million standard axles. 21.005 MSA. So it is simple. 21 into 10 to the power of 6. So 21 MSA, million standard axle. Option is C. Simple. Next, the average daily traffic, the average daily traffic, the average daily traffic of a stretch of a road is 300 commercial vehicles per day. Design traffic repetitions for 10 years when vehicle damage factor is 2.5 and growth rate is 7%. That is 3000, I think. 300. Try to solve this by 300. If not, change it to 3000. So A value is given as 300. A value is given as 300. Rate of growth of traffic is 7%. Rate of growth of traffic is 7% and design life in 10 years. This is 10 and VDF is 2.5 only anyway. What is this value? Please give me the answer. Sir, why you are making us to do this? See, the questions are being asked a lot in this. So why? There is nothing wrong in practicing it. Practice it. Please give me the answer. What is the answer? Please give me the answer. N value, please give me the answer. Three point seven 10 to the power of 6. So 3.7, you can simply say 3.7 MSA, right? 3.7 million standard axles. Option is there. Yeah, 3.8 is there. So option is A. Simple. Fine. This is one of the way to solve this. The following data pertains to the number of commercial vehicles per day for design of flexible pavement for a national highway as per the thing. The type of commercial vehicle, 2 axle trucks, tandem axle trucks, number of vehicles per day, considering the lanes is 2000, vehicle damage factor is 5, tandem axle trucks 200, vehicle damage factor is 6. Okay. Next, assuming traffic growth rate as 7.5% per annum for both type of vehicles, the cumulative number of standard axle load repetitions for design life of 10 years is, N is given 10 years, growth rate is R is 7.5. Here see and try to understand number of vehicles per day considering the number of lanes, 2000, VDF is 5, and here 200, VDF is 6, vehicle damage factor is 6. He is asking cumulative number of standard axle load repetitions. Please give me the answer for this. Please give me the answer. What is the answer? (56.9 MSA). So how exactly you're going to solve this is, two things are given to you. Two types of vehicles are given to you. So how exactly you're going to find this out? N value. Just calculate for different things separately. So N value would be equals to 365 multiplied with, in first case, A is 2000. A is 2000 multiplied with 1 plus R is 7.5 upon 100. What is the design life period that is given to you? Design life period that is given to you is 10 years. Design life that is given to you is 10 years. 10 minus 1 whole thing upon 7.5 upon 100 multiplied with, what is the VDF for 2000 vehicles? What is the VDF for 2000 vehicles? VDF is 5. So this value would be 5 multiplied with 1 multiplied with 1. So what is this value you are getting? Next, for tandem axles. Tandem axles are different from two axles. Okay. So this is 365 multiplied with number of tandem axles, tandem axle trucks, two axle trucks, both are different. So this is 200 multiplied with 1 plus 7.5 upon 100 to the power of 10 minus 1 whole thing upon 7.5 upon 100 multiplied with 6 multiplied with 1 multiplied with 1. So what is this answer? N. I'll take this as N1, N2. What is this value and what is this value separately? Can you please tell me? Can you please tell me what is this? What are these values? These two values. What are these values? Can you please tell me N1 and N2 separately? Make it fast, and finally total N would be equals to N1 plus N2. That's it. Here there is nothing big. He just gave that to confuse you. That's it. Please do that. Just a minute. Please give me the answer, guys. N1 and N2. Please give me the answer. Just take separately and add it. What is N1? What is N2? I have taken common as 365. whatever that is common. Okay, you have taken common anyway. You got how much? 57.6 MSA. Fine, there is an option like that. There is an option regarding that, so not a big issue. Go with it. Your option is 57.8. Option is B. Fine, well and good. 57.8. Okay, fine. Next problem. Next problem. A pavement designer has arrived. A pavement designer has arrived at a design traffic of. A pavement designer has arrived at a design traffic of 100 million standard axles for a newly developing national highway. Okay, as per IRC 37 guidelines, using the following data: design life is 15 years. Design life is 15 years. Commercial vehicle count before the pavement construction is 4,500 vehicles per day. Traffic growth rate is 8%. What is the vehicle damage factor used in the calculation? Fine. So in this problem, what is given to you? N value is given to you. N equals to 365 into A multiplied with 1 plus R upon 100 whole to the power of N minus 1 upon R upon 100 multiplied with lane distribution factor, vehicle damage factor, and load safety factor. Okay, so N value is 100 million standard axles. So that means 100 into 10 to the power of 6, 365 multiplied with A, 4,500 vehicles per day, 4,500 vehicles per day, and 1 plus R upon 100. R is 8%, 8 upon 100 to the power of design life, N value, 15 years. 15 minus 1 whole thing upon 8 upon 100. And LDF. What is the value of LDF? LDF is not given. We have to find out the value of VDF. So this is 1 VDF multiplied with 1. Directly give me the value of what is the value of VDF. That's it. The question asked is something like this. Simple. So what is the value of VDF? Please give me the answer. R 2.24, Soumya is saying 4.8. So which one of these two things? There is 4.14, 2.24. Soumya, please try to correct. I think there is no 4.8. Please do it one more time. What is the value you are getting? Please let me know. What is that value you are getting? Please let me know. Please make it fast. Please make it fast. .24. I don't know. Please see this 2.24 or something like that. Soumya, make it fast. Please do like, share, subscribe. Fine. Next, a traffic survey conducted on road yields an average daily traffic count of 5,000 vehicles. The axial load distribution on the same road is given in the table, given in the following table. Axial load, frequency of the traffic. The design period of the road is 15 years. The yearly traffic growth rate is 7.5% and load safety factor is 1.3. If vehicle damage factor is calculated from the above data, then design traffic in million standard axials is. Fine. So what he has given over here, a traffic survey conducted on the road yields an average daily traffic count of 5,000 vehicles, right? So it yields an average daily traffic count of 5,000 vehicles. The axial load distribution on the same road is given in the table. This is the axial load, frequency of the traffic that is given. The design life period of the road is 15 years. Design life period of the road is 15 years. Traffic growth rate is 7.5%. Load safety factor is 1.3. The VDF is to be calculated from here. Okay. And the design traffic in million standard axials is. How you are going to solve this? So here comes the concept of equivalent axial load factor, EALF. Equivalent axial load factor. Equivalent axial load factor. A value anyway it is given as 5,000 vehicles per day. Not a bigger issue. 5,000 vehicles per day. And design life is given as 15 years. N equals to 15 years. R equals to 7.5%. And LSF, load safety factor, equals to 1.3. And you have to calculate VDF from the table. So the axial load is given to you. I told you vehicle damage factor is the one which converts normal axial to standard axial. What is the standard axial load? Standard axial load, if nothing is mentioned, you will be taking it as 8.2 tons. 8.2 tons. Fine. 8.2 tons. Now, frequency of repetition 10%. That means out of 100 times, this will be repeated for 10 times. This will be repeated for 20 times. This will be repeated for 35 times. This will be repeated for 15 times. This will be repeated for 20 times. 10 repetitions of this equals to how many repetitions of 8.2 tons? That means, let us say frequency is 10%, I am saying, right? So, if it is moving for 100 times, 18 tons load is moving for 10 times. Out of 100, 10 times it is moving. Then, what is the repetitions in terms of 8.2 tons load? How will you calculate this? 10 multiplied with L upon Ls to the power of 4, right? Here you will be using equivalent axial load factor, that is 10 multiplied with 18 upon 8.2 to the power of 4. This is the repetitions in terms of 8.2 tons. Fine. Since this is less, there will be more repetitions. Okay. So how will you calculate this? VDF. Now first calculate the number of repetitions. 10 multiplied with 18 upon 8.2 to the power of 4 plus this is 20, 14, right? So 20 multiplied with 14 upon 8.2 to the power of 4 repetitions. Frequency means number of times it is repeating, how frequently it is occurring. Fine. 35 multiplied with 10 upon 8.2 to the power of 4 plus 15 multiplied with 8 upon 8.2 to the power of 4. Next, finally it is 20 upon 20 multiplied with 6 upon 8.2 to the power of 4. Fine. So this is the thing. Whole thing upon total number of repetitions, that is 100. Fine. from this calculate what is the value of VDF. So that is what I said. By using VDF, we will convert this number of repetitions of normal load to the standard axial load. This is the value of VDF. Please give me the value of VDF. Once if you know VDF, N value would be equals to 365 multiplied with A is 5000 multiplied with 1 plus R is 7.5 to upon 100 to the power of N is 15 minus 1 whole thing upon 7.5 upon 100 multiplied with LSF. LDF is not given, it is 1. VDF you have to tell me, and this is 1.3. What is this value N? Please tell me. What is the value of VDF? What is 8.2? I don't know what is meant by 8.2 you are trying to say, but just tell me what is the value of VDF. Tell me the value of VDF, please. Sir, still axial load is 8.2. I am asking what is the value of VDF. Please give me the value of VDF. I don't know what you are trying to say regarding that. What is the value of VDF? Please let me know. 8.2 tons only, because this is given in tons. You have to take that in tons. Still axial load 8.2. You are saying million standard axles is 8.2 or VDF 8.2. What is the answer? What is VDF and what is N? Please give me the answer. $4.988 is what? VDF. 4.988 is VDF. And what is the value of N? VDF 5. Okay. What is the value of N? N is 8.2 you are saying? What is N? N. What is the value of N? $309.12. 309.12 into 10 to the power of 6, that is 309.12 million standard axle. So please be very clear with this. Here it is 4.988. I don't know. See, axial load you will be taking it as 8.2 tons only. Fine. So this is how you will try to calculate. Any doubts in this? You can ask me. Any doubts? Yeah. So this is how you will try to solve. So these type of problem, that is the reason equivalent axial load factor is given to you in order to convert the axial load repetitions. Fine. Next. Fine guys, so I think with this try to solve this question. The following observations were made on an axial load survey. The axial load, number of repetitions per day. The standard axial load is 80 kilonewtons. Equivalent daily number of repetitions for standard axial load is. He is asking what is the equivalent daily number of repetitions for standard axial load. Use the concept of EALF, equivalent axial load factor. Fine. Please do this and let me know what is the answer. I think there is some network issues because if you are answering at starting only, I am getting answers delayed. Anyway, please give me the answer for this. The following observations were made of an axial load survey on the road. Standard axial load is 80 kilonewtons. Equivalent daily number of repetitions for the standard axial load, Atul has given 450. So how you are taking 35 to 45, you can take approximately 40. And 75 to 85 you can take approximately 80. So for 40 kilonewtons repetitions is 800, and for 80 kilonewtons repetitions is 400, and for 80 kilonewtons repetitions is 400. So number of repetitions he is asking, that means equivalent you have to use just EALF concept, that is fourth power law, L upon Ls to the power of 4. So for 40 kilonewtons 800 repetitions. For 80 kilonewtons how many repetitions? 800 multiplied with 40 upon 80 to the power of 4 plus, once again for 80 kilonewtons 400 repetitions, standard axial load is also 80. So this is 80 upon 80 to the power of 4. So what is this value? So this is 50 plus 400. So the value would be 450. Value would be 450. Okay. Any doubts in this? You can ask me. Soumya, it is not 800. It is 450. He is asking what is the standard axial load repetitions in terms of 80 kilonewtons. That means these two axials are there. Totally, if you want to convert everything, the total standard axial load repetitions would be 450. Okay. Any doubts in this? You can ask me. Fine. So flexible pavement, maximum number of points we have tried to see in flexible pavement without much of an issue. Okay. Now, so in flexible pavements, the code that is used is IRC 37 2018 right now. Okay. And flexible pavement, the load is being transferred from grain to grain contact. Right. So flexible pavements, and there is a question, the position of base course in the flexible pavement. So the position of base course in the flexible pavement would be what? In flexible pavement, if you see, there is soil subgrade, sub-base course, base course, and surface course. Soil subgrade, sub-base course, base course, and surface course. Okay. So base course is in between sub-base course and surface course. Okay. And here the load, whenever load is being applied, it transferred from grain to grain contact. Load is transferred from grain to grain contact. Load is transferred through grain to grain contact. through grain to grain contact, and the code that we will be watching for this would be IRC 37 2018. Fine, this is the latest code that you are going to see for this, and the other points over here would be uh, here the initial cost is less, but maintenance cost will be very much high, and if there is any failure in the bottom, it will be seen at the top. Localized failure is not contained. If there is failure at the bottom, it will be seen at the top, so localized failure is not contained. Okay, so these are the points that you will be generally seeing in the flexible course, flexible pavements. Okay, now comes the rigid pavement. Rigid pavement. Rigid pavement. Fine. So in rigid pavement, you don't see subbase course. You won't see subbase course. There will be soil subgrade, base course, and cement concrete pavement on the top. Soil subgrade, base course, and a cement concrete pavement on the top. Cement concrete pavement. Fine, this is how it would be. Here, this is like slabs. These will be generally like slabs. Sir, S1ER19 lol on in. What is that, Bullock? I don't understand. Please let me know what exactly you are trying to say. Fine. Cement concrete pavement, base course, soil subgrade. Here, load is transferred by slab action. Load is transferred through slab action. Fine. So load is transferred by slab action. That means whatever the load, the slabs that you will be seeing in the RCC, the load will be transferred through slab action. Same thing, saucer type of bending, all those things you will be seeing here. And here you will be using IRC 582018. So high initial cost and low maintenance cost. But anyway, recently we are not going for flexible or rigid pavement. We will be going for combined. Like, flexible on the top of the rigid pavement, you will be using a bituminous course. Fine. Or in the base course, you can apply some amount of cement. These type of pavements, composite type of pavements we are going for right now. Fine. So because we can use both advantages of flexible pavement and rigid pavement at the same time. All the highways is on the top, you will be seeing bitumen only. You won't be seeing cement pavements. Why? Because bitumen is more flexible. Flexible means it can go like this, it can expand and it can come back to its original position. Whereas cement pavements, there will be, if cracks are developed, it will be of more problem. Or even if you are putting cement on the top, we'll try to provide a bituminous course. Fine. We'll try to provide a bituminous course. So these are the points that we generally see. And localized failure is contained. That means if at all there is any failure at the bottom, it is not seen at the top. Localized failure is contained. If there is failure at the bottom, it is not seen at the top. These are the points that we generally see in the rigid pavement. And before going into the dealing with the rigid pavement, we should know plate load test. So plate load test is conducted to find out indirectly to find out the strength of the soil, that is given in terms of modulus of subgrade reaction. Modulus of subgrade reaction. This shows the strength of the soil. Strength of the soil is given in terms of modulus of subgrade reaction. That is obtained from the plate load test. So that means what exactly you will be doing over here is, let us say this is the soil subgrade. On the top of the soil subgrade, you will keep a plate. The plate can be different shapes. It can be square, circular, be a truss type of loading. So we'll try to apply the load. We'll try to apply the load, and on the top of the plate there will be dial gauges, and there will be proving ring also, which will give you the load. Dial gauges will give you the deformations, and proving ring will give you the load. These are dial gauges. Okay, this is plate. Plate can be square or circular. Square or circular. Generally sizes vary from 30 centimeters, 45 centimeters, 60 centimeters, 75 centimeters. Okay, standard size of the plate is generally taken as 75 centimeters. Standard size of plate is 75 centimeters. Standard size of plate is generally taken as 75 centimeters. Now you will keep on applying the load. From dial gauges we are going to measure the deformations or deflections. You will keep on applying the load. From dial gauges you will try to measure the deformations or deflections. Proving ring will be there. Proving ring will also be somewhere here, where you can see the load. There will be a proving ring which will give you the load. Proving ring. Now based on this we'll try to draw load versus deformation curve. Load versus deformation or load versus deflection curve. Load versus deflection curve. This is load in kgs versus deformation or deflection. Deflection or deformation. Deflection or deformation. Fine. So the curve would be something like this. Fine. And let us say this is P and this is delta. Generally at the delta of 1.25 centimeters we'll try to find out what is the modulus of subgrade reaction. So modulus of subgrade reaction, generally K. The strength of the soil is given in terms of modulus of subgrade reaction, that is given as P upon delta. Generally we'll take it as delta at 1.125 centimeters. Fine. So this is kgs and this is centimeter square. Sorry. Actually we'll take this as stress. Okay. Stress versus deformation curve. Okay. Okay. Actually from the load we'll try to find out the stress. Okay. Let us say this is load only. This is kgs. P, small p would be equals to load multiplied upon area. Load upon area. So this would be P upon pi a square, where a is the radius of plate. Radius of plate. Anyway, so this is small p upon centimeter. So kg per centimeter square, and deflection units is centimeters. So units of modulus of subgrade reaction. Modulus of subgrade reaction indirectly gives you the modulus of subgrade reaction indirectly gives you the value of K. Fine. It will indirectly give you the strength of the soil from plate load test. It is P upon delta, where P equals to kg upon centimeter square, delta is centimeters. Generally it is taken at 0.125 centimeters. Standard size of the plate is taken as 75 centimeters. Okay. For plate load test, if you are seeing, deflection is generally given as 1.15 PA upon ES. So 1.18 PA upon ES. This you will get from different calculations. Anyway, this is for plate load test. Plate load test, where ES is the modulus of elasticity of subgrade. Modulus of elasticity of subgrade. Modulus of elasticity of subgrade. Find soil subgrade. I am talking over here. Find P is the stress. A is the radius of area. radius of area of the plate. Okay, so from this what you can write, K equals to generally P upon delta, that is ES upon 1.18 times A. So what you can write, K is inversely proportional to A. K is inversely proportional to A. Modulus of subgrade reaction is inversely proportional to radius of contact area. So what you can write is K1A1 equals to K2A2. K1A1 equals to K2A2. Modulus of subgrade reaction is K1A1 equals to K2A2. This is one of the point. And soaked and unsoaked. If soil is soaked, then strength taken by it would be less. If soil is unsoaked, then strength taken by it will be more, right? Soaked means it is kept in the soil. So if soil is soaked means if it is wet, and if you apply the load, deflection at the same load, deflection will be more, right? So this is soaked case. This is soaked. This is soaked, and this is unsoaked. This is unsoaked. If I take this is the stress, delta 1, delta 2, K value for unsoaked, if I have to write, that is equals to P upon delta 1, K value for soaked, that equals to P upon delta 2. Delta 2 is more than delta 1. So K of soaked will be less than K of unsoaked. K of soaked will be less than K of unsoaked. This is how you will try to find out K, the variation of the K in different cases. The major idea is modulus of subgrade reaction, which plays an important role in finding out the stresses, everything throughout your rigid design of rigid pavement. Will be using this concept only. Fine. See, if this is plate load test, if you are doing wheel load test, the only difference would be wheel load test. If you are doing wheel load test, then delta would be equals to 1.5 times PA upon ES. This is the only difference. If it is plate load test, delta would be equals to 1.18 times PA upon ES. If it is wheel load test, it is 1.5 times PA upon S. This is generally done for flexible pavement, and this is generally used in design of rigid pavement. Okay, so these are the points that you have to generally remember. Now, if you have to see the problems based on this modulus of subgrade reaction, so what is the unit of coefficient of subgrade modulus? That is modulus of subgrade reaction. This is how generally it is. What is the value that I have given? That is kg per centimeter cube. That can be taken as indirectly kilonewton per meter cube, right? Both will remain same. Kilonewton per meter cube. Your option would be A. Fine. So this is how you can find out this. Next. Try to solve this question. The plate load test conducted with a 75 centimeters diameter plate on soil subgrade yielded a deflection of 2.5 mm under a stress of 800 Newton per centimeter square. The modulus of elasticity of the subgrade in kilonewton per centimeter square is. What is the modulus of elasticity of subgrade in? He is not asking modulus of subgrade reaction, he is asking modulus of elasticity. Read the question properly and give me the answer. Plate load test conducted with a 75 centimeters dia plate on a soil subgrade yielded a deflection of 2.5 mm under a stress of 800 Newton per centimeter square. What is the modulus of elasticity? If plate load test is conducted, you will be using this formula. So 1.18 and P value is 800 Newton per centimeter square. This is 800 Newton per centimeter square. Units are important. Newton per centimeter square. And A value, what is the value of A? A is 75 centimeters. This is 75 centimeters. Whole thing upon ES multiplied with equals to delta. Delta is 2.5 mm. That is 0.25 centimeters. So just tell me the value of ES in terms of newtons per centimeter square and convert that into kilonewton per centimeter square. Give me the answer. What is the answer, guys? Make it fast. He said plate load test. When your plate load test is being applied, delta is something like this. So what is the answer? Soumya has given answer as 283.2. Option is not there, Soumya. Option is not there. Do it properly. 1.18. The value is 1.18. Please do it properly. Plate load test is being conducted. 75 centimeters diameter plate. The major mistake many times I'll do is 75 centimeters diameter. Dia is 75 centimeters. So radius would be 75 by 2. That is 37.5 centimeters. So this is 75 by 2. Please give me the answer. ES. $75 by 2, yeah. Please give me the answer. $141.6 kilonewton per centimeter square you are getting. Units are very much important. 141.6, it should be kilonewton per centimeter square. 141.6 kilonewton per centimeter square. Value is A. If it in newtons per centimeter square, I think you will get this 141.6 into 10 to the power of 3 Newton per centimeter square. That equals to 141.6 kilonewton per centimeter square. Fine. This is how you will try to find out ES value. Okay. Modulus of subgrade reaction is evaluated from plate bearing test. This is some basic problems these are. So the modulus of subgrade reaction is obtained from the plate bearing test in the form of load deformation curve. The pressure corresponding to the following settlement value should be used for computing modulus of subgrade reaction. So you will be using pressure corresponding to delta equals to 0.125 centimeters. So K value would be equals to P upon delta, delta equals to 0.125 centimeters. Fine. So that is how you will try to find out. What is that C? Yeah, C. Okay, fine. A plate bearing test was carried out. A plate bearing test was carried out on a subgrade using a 76 centimeters dia rigid plate. The deflection of 1.25 mm was observed by a pressure was caused by a pressure of 0.84 kgs per centimeter square. The modulus of subgrade reaction in kg per centimeter cube. What is the answer? So pressure given is 0.84 kgs per centimeter square. K equals to simply P upon delta, that equals to 0.84 kgs per centimeter square. Delta 1.25 mm, convert that into centimeters, that is 0.125 centimeters. This is kg per centimeter cube. So what is the value of K? Please let me know. What is the value of K? What is the value of K? Please let me know. That you are getting. What is the value of K you are getting? Please let me know. What is the value of K? 0.84 upon 0.125. 84 upon 12.5. So 12 sevens are 82. Approximately you will get 7 kgs per centimeter square. Approx centimeter cube. Okay, 7 kgs per centimeter cube. That is one of the thing. Next, plate bearing test with a 20 centimeters. Plate bearing test with a 20 centimeters dia plate on a soil subgrade yielded a pressure of 1.25 into 10 to the power of 5 Newton per meter square at 0.5 centimeters deflection. At 0.5 centimeters deflection, what is the elastic modulus of subgrade? He is asking to find out ES. Please try to solve it. Plate bearing test with 20 centimeters plate. Plate bearing test is done with a 20 centimeters dia plate. So A would be 20 upon 2, that equals to 10 centimeters. And yielded a pressure of 1.25 into 10 to the power of 5 Newton per meter square. 10 to the power of 5 Newton per meter square. Fine. At a deflection of 0.5 centimeters. 0.5 centimeters. So this would be 5 into 10 to the power of minus 3 meters. This would be 10 centimeters, that is 0.1 meters. 0.1 meter. Everything try to convert that into meter. What is the elastic modulus of subgrade? So delta would be equals to 1.18 PA upon ES. From this substitute everything. Delta is 5 into 10 to the power of minus 3. 1.18. P is 1.25 into 10 to the power of 5. A. Area is A is 0.1 upon ES. So what is the value of ES? Please let me know. What is the value of ES? What is the value of ES? Please let me know. What is the value of ES? Please let me know. 29.5 into 10 to the power of 5. 29.5 multiplied with 10 to the power of 5 Newton per meter square. He is asking in terms of Newton per meter square. So your option is B. Your option is B. Your option is B. So any doubts in this? Your option is B. Any doubts in this? The standard plate in plate bearing test to find out the modulus of subgrade reaction is, what is the size of the standard plate? In plate bearing test to find out the modulus of subgrade reaction, standard size of the plate is 75 centimeters. That I have already discussed. 75 centimeters, okay. Fine guys, so this is how we'll try to solve problems on this. Anyway, let's take a break for another 10 to 15 minutes. I think it's 11:20 now, maybe 11:30 or 11:40 we'll try to meet, and then we'll see how to design the rigid pavements. Rigid pavements, like we'll see from the starting everything, what are the types of stresses, how to find out those stresses, combination of the stresses and everything. We'll try to solve problems on that. Okay, fine, thank you. Let's meet at 20 minutes later. Bye. So, hi friends, anyone there? If you're there, please do comment. Please do comment. So, you have completed 95% of syllabus, but in mock I'm getting 40 to 50 marks only. What to do feeling demotivated? Praveen, the idea is very simple. From the starting I am saying, don't worry about your marks in the mock test and don't worry about your rank in the mock test, because that doesn't mean that it will give you the first rank in the gate examination. The idea what you have to see over there is what is the mistakes that you are doing. That means if you are getting 40 to 45 marks, is it because there are any new concept, or is it because of some conceptual mistakes that you don't know the concept, you have just mugged up the concept and you're trying to vomit over there, or if you are doing any calculation mistakes. The thing is, you have to analyze what is the mistake. If you know what is the mistake, the next part you can easily correct the mistake. The major thing people don't understand is finding out what is the mistake, what mistake they are doing. Fine. So if you just try to find out this is your mistake, then you can easily correct your mistake. Try to find out your mistake and then we can go forward in the future. Fine. So don't worry about marks. If it is not marks, let us say if you are getting 100 out of 100 over here, that doesn't mean you'll get 100 out of 100 in the gate. Okay. It just to feel motivated or demotivated, the first rank over here, last rank over here doesn't mean anything. The only thing that means is what is the effort you are putting in it, and what is the type of mistake is happening over there, and how you are correcting it. Just like you just have simple, it's very simple. You open it, what are the mistakes you have done, see that mistakes, correct it, understand why you are doing that mistake first, why that mistake has happened. That question is, if it is new concept, leave it, learn the concept. If it is a concept that you know and you're doing mistake, then don't repeat it. Learn that concept properly from whoever the lecturer that you want to learn from him properly. And if it is calculation mistake, don't repeat that mistake. These are the only three things that happens. Don't tell me, sir, I don't remember. If you don't remember, then you need more practice to remember. Then practice more questions to remember that concept. As simple as that. Okay, fine. Next now there are certain parameters in design of the rigid pavements that we have to see. First, we have seen modulus of subgrade reaction, right? Modulus of subgrade reaction. Modulus of subgrade reaction, that is generally given as K equals to P upon delta. At delta 0.125 centimeters in kgs per centimeter cube, you will get it. Okay. Next point in this is radius of relative stiffness. Radius of relative stiffness. Radius of relative stiffness, which is specified as L, that is generally given as EH cube upon 12k multiplied with 1 minus mu square whole to the power of 1 by 4. This is a radius of a relative stiffness. What exactly this means is, whenever you are applying the load, let us say there is a pavement and you are applying the load on the pavement. You are applying the load on the pavement. There is an area below the pavement. There is an area below the pavement which resists this load. There is an area below the pavement which will resist this load. There is an area below the pavement which will resist this load. The radius of this area is called as radius of relative stiffness. The soil below the pavement, this is the pavement and this is the soil, right? This is the pavement and this is the soil below the pavement. Soil below the pavement will resist some amount of load, that is called, this radius of this area is called as radius of relative stiffness. That is generally given as EH cube upon 12k multiplied with 1 minus mu square, where E equals to Young's modulus of the pavement, 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 and H equals to thickness of the pavement, H equals to thickness of the pavement, H equals to thickness of the pavement. K equals to modulus of subgrade reaction. K equals to modulus of subgrade reaction. K equals to modulus of subgrade reaction. Mu equals to Poisson's ratio. Mu equals to Poisson's ratio. Fine. So substitute, you'll get this. You'll get this in terms of centimeters. Fine. This is a radius of a relative stiffness L. Fine. And next one is radius of actual resistance. Radius of actual resistance. Actual resistance or relative resistance. Relative resistance, that is generally given as B. B equals to under root of 1.6 A square plus H square minus 0.675 H if A is less than 1.724 H, and this is the value of A if A is more than 1.724 H. What exactly is this? This is the area that is effective in resisting bending moment. That means whenever load is being applied, this is reaction. Radius of relative stiffness is effective in resisting reaction, whereas when this tries to bend, there is a soil below this that tries to resist that bending moment. Fine. So that is the radius of actual resistance. Area that is effective in resisting bending moment. Area that is effective. Area that is effective in resisting bending moment. In resisting bending moment. Area that is effective in resisting bending moment. Fine. So these are the points that you have to generally remember. This is the value of B, where A equals to radius of contact area. Radius of contact area, and H equals to thickness of pavement. H equals to thickness of pavement. These are the parameters that you have to generally remember. Throughout your design of rigid pavements, we'll be using these concepts only. Fine. Next, let's try to solve problems on this. So a problem that is given to you is the radii of relative stiffness of rigid pavements P and Q are denoted by LP and LQ respectively. The geometric and material parameters of the concrete slab underlying soil are given below. This is the concrete slab and subgrade reactions, the ratio of LP to LQ. He is asking what is the radius of relative stiffness of pavement P to pavement Q. So length of the slab is L, width is H, thickness is H and 0.5 H, radius of modulus of elasticity EE, Poisson's ratio is same, modulus of subgrade reaction for one thing it is K and for other thing it is 2K. So please give me the answer. Please give me the answer. What is LP to LQ? I think now it is visible. Please just give me what is LP to LQ. Atul is the one who is commenting. There are many people that is watching, and why they are not commenting, I don't know. So LP equals to L equals to what I have given, EH cube upon L equals to EH cube upon 12k multiplied with 1 minus mu square whole to the power of 1 by 4. So LP for LP, E equals to E, H equals to H, mu equals to mu, K equals to K, right? So this value would be EH cube upon 12k multiplied with 1 minus mu square whole to the power of 1 by 4. And for LQ, H equals to 0.5 times H whole cube upon 12, K is 2 times K, 1 minus mu square whole to the power of 1 by 4. So this is 1 by 2 to the power of 4, it would be 1 by 2. So 1 by 2 times EH cube upon 12k multiplied with 1 minus mu square whole to the power of 1 by 4, that is 1 by 2 times LP. LQ equals to 1 by 2 times LP. So LP upon LQ would be equals to 2 upon 1. LP upon LQ equals to 2 upon 1. Fine. So this is how simply you'll try to calculate. Any doubts you can ask me. Any doubts you can ask me. Yeah, fine. So that is the answer. Direct application of formula. Nothing else is there in this. Try to solve this question. The radius of relative stiffness for a 20 centimeters thick slab and E equals to 3 into 10 to the power of 5 kgs per centimeter square, and Poisson's ratio is 0.15 and modulus of subgrade reaction is 5 kgs per centimeter square. What is the radius of relative stiffness, he is asking. Please try to calculate. H equals to 20 centimeters. H is given as 20 centimeters. Fine. H is 20 centimeters. E equals to 3 multiplied with 10 to the power of 5 kgs per centimeter square. Kgs per centimeter square. Poisson's ratio equals to 0.15 and modulus of subgrade reaction, K equals to 5 kgs per centimeter cube. Actually it is not square. Modulus of subgrade reaction, modulus of subgrade reaction 5 kgs per centimeter cube. So from this, what is the value of L, he is asking. Just substitute EH cube upon 12k multiplied with 1 minus mu square whole to the power of 1 upon 4. So E value is 3 multiplied with 10 to the power of 5 H cube. H is 20 whole cube upon 12k. K is 5 multiplied with 1 minus 0.15 square whole to the power of 1 by 4. So what is the value of L, radius of relative stiffness? 79.98 centimeters. Atul has given 79.98 centimeters. What about the other people? Praveen, at the starting of the class, I have given the explanation to it. Praveen, so please see that starting of the class means after the break, I have given answer to your question. So please look at it. So Atul has said the answer is 79.98 centimeters. So approximately 80 centimeters. Other people, are you getting the same answer? Please let me know. If you are getting the same answer, please let me know. Yeah, Soumya is also getting the same answer. So this is how you'll try to solve these type of questions. Fine. So that is how you'll try to find out what is that radius of relative stiffness. Now coming to the rigid pavement, stresses in the rigid pavement. Stresses. The different types of stresses. First one is wheel load stresses. Wheel load stresses. Stresses due to wheel load. Stresses due to wheel load is critical at corner and edges. Critical at corner, critical at corner and edges. Critical at corner and edges, and not critical at interior. Not critical at interior. Okay, so that means because of the load, these are mechanical stresses, not temperature stresses. The load due to the stresses that is developed because of the load. So because of the load, the stresses will be developed at the bottom. Fine, this is interior. Fine, why it is not critical at the interior? Because resisting area is high. Resisting area is high. Fine. So this is interior. See how, sir, how we are going to see the interior edges and all those things. Fine. So this is considered as interior. If you are applying the load here, this is interior. Okay. This is corner, and this is edges. This is edges, this is corner, and this is interior. Fine. So these are the thing. Generally, if you see the type of stresses that is developed at the interior, the stresses developed, if they ask at the interior, if they ask stresses, because of that, at the interior it tries to bend like this. So top will be under compression, bottom will be under tension, just like a slab. It tries to bend like this. So at interior, top portion of slab will be under compression. Top portion of slab will be under compression. Bottom portion of slab will be at tension. Bottom tension. At interior and edges also. And edges also. At interior and edges, top will be under compression, bottom will be under tension. It tries to bend like this. Fine. And if you try to apply the load at corners, if you try to apply the load at corners, if you try to apply load at corners, it will try to bend something like this. Fine. So top will be under tension, bottom will be under compression. So at corners, due to wheel load, at corners due to wheel load, top will be under tension, top will be under tension, bottom will be under compression, bottom will be under compression. Due to wheel loads, top will be at corners, top will be under tension, bottom will be under compression, and at interior edges, top will be under compression, bottom will be under tension. So this is due to wheel loads, and there are different formulas if you want to find out wheel loads, which is generally not that much important. But if they ask 0.316 P upon h square 4 log L by B plus 1.069, and at the edges, if they ask 0.572 P upon h square 4 log L by B plus 0.359. All these things are Webster's method. Webster's method. Webster's method. And at the corners, if they ask 3p upon h square multiplied with 1 minus a root 2 upon L to the power of 0.6. Fine. Where P is the load applied, H is the thickness of the pavement, L is the radius of relative stiffness, B is the radius of actual resistance, and A is the radius of contact area. All these things you will be getting this in kgs per centimeter square. Generally problems will not be asked from here. If at all it is asked, then you have to attempt it in a better fashion. Kgs per centimeter square. This is how Webster's method, stresses due to wheel load. SI represents interior stresses, SE represents at the edges, SC represents at the corners. Stresses due to wheel load. stresses due to wheel load. Stresses due to wheel load. Fine. This is one of the point. Next point. Next is temperature stresses. In temperature stresses, there are two things: warping stresses and frictional stresses. Warping stresses is due to daily variation of temperature. Warping stresses due to daily variation of temperature. Fine. So warping stresses is due to daily variation of temperature. So if it is daily variation of temperature, warping stresses is due to daily variation of temperature. So now generally it is critical at interior and edges, but not at corners. Generally it is critical at interior and edges, but not at corners. Anyway, if I take any pavement during daytime, what happens is top members tries to expand, bottom member tries to contract, right? Top member tries to expand like this, and bottom member tries to contract, right? Top member tries to expand, bottom member tries to contract, because temperature here is more compared to that of this one. Temperature at top is more than temperature at bottom. Temperature at top is more than temperature at bottom. So top member will try to expand, bottom member will try to contract. But load will be acting downwards, right? Load will be acting downwards. Self weight of the thing will be acting downwards. Since self weight is acting downwards, so what happens is there will be stresses that is developed in this direction. That means it tries to expand, but load will not allow it to expand. So what we can say over here is it tries to go like this. Stresses will be developed something like this. That means because of temperature it tries to expand, but this load will resist. Here also because of temperature it tries to contract, but load will resist it. So the stresses developed would be top will be tension, top will be under compression, bottom will be under tension. Top will be under compression, bottom will be under tension. So warping stresses during daytime, top will be under compression, bottom will be under tension. Fine. You have to be very much clear. Top will be compression, bottom will be tension. Similarly, during night time, what happens is, if let us say this is the pavement, then during night time top members will try to contract and bottom member will try to expand, because temperature at top is less than temperature at bottom, right? Temperature at top is less than temperature at bottom. Top members will try to contract and bottom members will try to expand. So, and load, self weight, if you see self weight will be acting somewhere here. Self weights will be acting somewhere here. Fine. Because of that it tries to contract, but due to self weight the stresses will be developed in this direction. So on bottom the stresses would be something like this. Stresses will be developed in this direction. Okay. So top will be under tension, bottom will be under compression. Bottom will be under compression. Top will be under tension, bottom will be under compression. Fine. So this is what you will be doing during night time: top tension, bottom compression due to warping stresses, and during daytime top compression, bottom tension. Fine. So these are the warping stresses that you will be generally seeing, and it will be critical at interior and edges but not at corners. Fine. Any doubts in this? You can go ahead and ask me. Sir, what is the relationship between degree and radius of curvature for different chain length? What I am discussing and what you are asking, Praveen. If you are having any doubts here, you can ask me, right? If you are having any doubts here right now, you can ask me. And if you are asking something else, any doubts up to here, guys? Please, if you are having any doubts, please raise the question. Any doubts up to here? No doubts? Fine. Next, warping stresses. There are different types of formulas. If I say Bradbury's formula, so SI in kgs per centimeter square would be equals to E alpha T by 2 multiplied with Cx plus mu times Cy upon 1 minus mu square, and SE in kgs per centimeter square equals to maximum of Cx E alpha T by 2 and Cy E alpha T upon 2. Fine. And SC in kgs per centimeter square, SC in kgs per centimeter square equals to E alpha T upon 3 multiplied with 1 minus mu under root of A upon L. Fine. Where Cx and Cy depends upon the length Lx and Ly. These are the parameters that should be given to you in the question if you have to solve. Okay. So the Cx and Cy are the parameters which depends upon Lx and Ly. Lx and Ly, from that you will get Cx and Cy. Fine. So parameters, it depends upon those parameters. Generally you don't have to remember these formulas. If you remember also, it's okay, well and good, but questions are not being asked from here, so you don't have to be worried. This is Bradbury's formula for warping stresses. Next comes frictional stresses. This is also temperature stresses. Frictional stresses. Stresses developed due to seasonal variation of temperature. Stresses developed due to seasonal variation of temperature. Fine. So stresses developed due to seasonal variation of temperature is frictional stresses during winters. So during winters what happens is the whole thing will try to contract, right? The whole pavement will try to contact during winters, right? That is resisted by the friction from the soil subgrade. If you take this as length Lx by 2, length of the pavement, this is also some Lx by 2, this would be width of the pavement, this would be width of pavement, and this would be the thickness of the pavement, h. If this is h, this is b, this is lx, this is also lx. So what happens is it tries to compress. During winter, what happens? It tries to compress, and the friction between the soil and the pavement will try to resist this. So the stresses will be developed in this direction. Stresses will be developed in this direction. That means what you can say is bottom is tension. Bottom is tension. That means indirectly the stresses would be something like this. Fine. Stresses would be something like this. Fine. If let us say F is the friction or subgrade coefficient, then what we can say over here is F multiplied with W. Load will be acting in the downward direction, right? Load will be acting in the downward direction. So what I can say, this frictional force is Fw, that is resisted by the stress SF. That is resisted by the stress multiplied with this cross-sectional area, right? So frictional stresses F multiplied with W would be equals to SF multiplied with B multiplied with H. W, gamma multiplied with volume. Volume equals to L multiplied with B multiplied with H, or L by 2 multiplied with B multiplied with H, that equals to SF multiplied with B multiplied with H. So SF, stresses developed in the concrete, is generally given as F gamma L upon 2, where gamma is the unit weight of concrete, unit weight of concrete, unit weight of concrete. So that is generally given as 24 kilonewton per meter cube, right? This is concrete, 24 kilonewton per meter cube. F value is generally taken as resistance, coefficient of subgrade restraint, coefficient of subgrade restraint. Restraint. So frictional stresses developed. Frictional stresses in pavement. If they ask what is the frictional stresses in the pavement, so this is the frictional stresses in pavement, and during winter in the bottom it is tension. During winter in the bottom it is tension. So top you can say compression, or which is negligible. Top it is compression, but anyway bottom is more important, that would be tension. That would be tension. And similarly during summer it will be opposite to this. During summer, top tension and bottom compression. Top tension and bottom compression. Fine. So this is the variation of the stresses. These are the different variations of the stresses that we generally see. Of course, I am discussing everything in detail, but this is worth. That is the reason I am discussing everything in detail. Okay. So finally, if I try to draw a table, winter, summer. So interior top portion under wheel load, top will be compression, bottom will be tension. Edges, top will be compression, bottom will be tension. Corner, top will be tension, bottom will be compression. Because of wheel, top will be tension, bottom will be compression. Warping stresses during daytime. During daytime, top will be under what? During daytime, top will be under compression, bottom will be under tension. During night time, top will be under tension, bottom will be under compression. Fine, same. Tension, compression, compression, tension, tension, compression. And winter, during winters, actually what we can say is whole thing, even you can't say top and bottom, everything will be in the tension only. Fine. So anyway, the majority would be bottom will be under tension, bottom will be under tension, bottom will be under tension. Here top will be under tension, top will be under tension, top will be under tension. Or you can say bottom will be under compression. Bottom will be under compression, bottom will be under compression, bottom will be under compression. To be more frank, you can take the whole thing will be in tension only. And whole thing will be in compression only. Top, bottom, it doesn't matter. Everything will be in tension only. And everything will be in compression only. Okay? Because I don't want you to get confused over here. Whole thing will be in the tension. Because of it tries to compress and this tries to resist. So whole thing will be in tension, and during summer whole thing will be in compression. So this is the thing. Okay. If they ask what is the critical combination of the stresses, so critical combination of stresses, if you ask me, winter, daytime, at the bottom, winter, daytime, critical combination of stresses will be there, because concrete is weak in tension. So during winter, daytime, at the bottom, stresses would be critical. You can say the same. Bottom during daytimes, winters during daytime, at the bottom it is critical. And during night time, winter, at the corner, top would be critical. Top would be critical. So this is the critical combinations of the stresses. You just have to see during which condition it will be critical. Tension, concrete is weak in tension. Based on that, during what times, how it will work, you have to see that. Okay. So any doubts in this, you can ask me. Any doubts in this, you can ask me. Any doubts, please do comment. I'm not getting any answers here. Please do comment if you are having any doubts, because I want us to solve some questions on this. This is one of the decent question. For a 25 centimeters thick concrete pavement, analysis of stresses gives the following values. Wheel load stresses during corner loading is 30 kgs per centimeter square, and wheel load stresses due to edge is 32 kgs per centimeter square. Wheel load stresses at corner during summer 9 kgs per centimeter, warping stresses at corner during summer 9 kgs per centimeter square. Warping stresses at corner region during winter 7 kgs per centimeter square. Warping stresses at edge region during summer is 8 kgs per centimeter square. Warping stresses at edge during winter is 6. Frictional stresses during summer is 5. Frictional stresses during winter, I think take that also as 5. So the most critical value of the stress for this pavement is please give me the answer. There is a pavement, wheel load stresses at corner 30 kgs per centimeter square. Wheel load stresses at edge, he is not mentioned about interior, at edge 32. Warping at corner during summer, warping at corner during winter, warping at corner at the edge during summer, warping edge during winter, frictional stresses during summer, frictional stresses during winter. What is the most critical value of this stress? Fine. So how we will see that? First, wheel load stresses at corner loading. Wheel load stresses at corner is 30 kgs per centimeter square. So this value is given as 30, 30, 30. Well and good. And this is 30 and 30. Wheel load stress at edge 32. Wheel load stresses at edge 32, 32. Okay. Warping stresses at corner during summer. Warping stresses at corner take it as daytime and night time. Warping stresses is because of daily variational stresses. Okay. Warping stresses at corner during day is 9, during night is 7. During daytime it is 9, during night time it is 7. Okay. Next, warping stresses at edge during day is 8, during night is 6. During day it is 8, during night it is 6. And stresses during summer is 5. Stresses during winter, it is not mentioned, take it 5 only. So stresses during summer is 5. Stresses during summer is how much? 5. Frictional stresses during winter is not mentioned. Anyway, take it as 5, 5, 5, 5. This also, if you take it as 5, take everything as 5. What is the critical combination of the stresses he is asking? Critical combination of the stresses. So this would be one of the critical combination of stresses during winter at bottom portion of the edge. During winter at bottom portion of the edge, 32 plus 8 plus 5, 45. During winter, bottom portion of stresses. During winter, bottom portion of edge. Bottom portion of edge during winter, daytime During winter, daytime bottom portion of the edge, 32 plus 8 plus 5, that is 45. I don't know what is that value, but anyway I have taken that as an example. 32 plus 8 plus 5, 45 kgs per centimeter square. Okay. Next at corner, if you see top corner, 30 plus 7 plus 5, right? Top corner, 30 plus 7 plus 5. So during winter, during winter, during winter, night time, top portion of corner, top portion of corner would be equals to 30 plus 7 plus 5, 42. 30 plus 7 plus 5, that equals to 42. See, this value is not given in the question. I have just taken it. Okay. I mean, there was some printing mistake, I think. I have just taken it. This is how you try to calculate. So your answer would be how much? 45 kgs per centimeter square. If there is option, yeah, option is there, 45 kgs per centimeter square. Simple. 45 kgs per centimeter square. So if you try to see, uh, just if you remember the table, if you know the variation of the stresses, you can easily find out. Not a bigger issue. So any doubts in this, you can ask me. Okay. Concrete is weak in tension. See where tension occurs. Here it is tension. Maximum value you have to take. Maximum value is 45. So this is the maximum value. That is the stress or critical stress. Critical portion where stresses will occur. So there were 31 likes. Now it is 30 likes. Someone disliked it. Kumar, thank you. I'll remember your name. Okay. You are the one who asked for it and you are not attending the class. Nice. Okay. 45 kgs per centimeter square. Any doubts in this, guys? Please let me know. Finn, I don't know where Finn is. He has left. He just asked for it and he left. Anyway, it happens. So what is the answer, guys? I mean, any doubts in this, guys? You can ask me. Any doubts? Any doubts? నేనేం గుర్తుంది ఇప్పుడు బాగా గట్టిగా అచ్చేసుకొని కూర్చుంటాను అది ఈజీగా వదలము ఎనీ డౌట్స్ నో డౌట్స్ ఫైన్ థ్యాంక్ యూ నా this is the critical combination of the stresses. Pradeep, you have asked for it. I don't know whether you are present or not. In a concrete pavement, try to solve this question. An isolated concrete pavement, an isolated concrete slab of length L, an isolated concrete slab of length L is resting on a frictionless base. The temperature at top and bottom fiber, the slabs are TT and TB respectively. Coefficient of thermal expansion is alpha. Modulus of elasticity is E. Assuming TT is more than TB and unit weight of 0. Unit weight is 0. The maximum thermal stress is calculated as. What is the maximum thermal stress? Please give me the answer. Sir. Of course, you have to prepare well, and I think already you have got prepared, right? This is revision and revision, quick revision this is, and you are asking me whether you have to prepare or not. ఆల్రెడీ ప్రిపేర్ అయిపోయాం కదండి, ఇంకేం ప్రిపేర్ అవ్వాలనుకుంటున్నారు? ఇందులో ఏమైనా డౌట్స్ ఉంటే ఇప్పుడే క్లారిఫై చేసుకొని ఎగ్జామ్లో పోయినామా చూసామా టిక్ కొట్టామా వచ్చామా అంతే. You just have to see what wheel load stresses top, bottom, corner, interior, edges, corner, and then warping stresses day, night, top, bottom, and then frictional stresses winter, summer. In winter it is tension, in summer it is compression. Simple. Accordingly you have to solve it. And if you ask me whether answer, okay, fine, solve this question. I'm asking you to solve the question only. Fine. An isolated concrete pavement slab of length L is resting on a frictionless base. The temperature of top and bottom fibers of the slabs are Tt and Tb respectively. Coefficient of thermal expansion is alpha and elastic modulus is E. Assuming something like this, unit weight of 0, the maximum thermal stress is calculated as. Please do like, share, subscribe. So free expansion as 0. Now Atul came to the situation. See, what he is saying is an isolated concrete pavement of length L, right? So concrete pavement, this is an isolated concrete pavement of length L. An isolated concrete pavement of length L. Fine. So there is an isolated concrete pavement of length L and it's resting on a frictionless base. There is no friction. That means F equals to 0. If F equals to 0, SF frictional stresses will be 0. Frictional stresses will be 0. Right? Frictional stresses is 0. Frictional stresses equals to 0. Fine. And temperature, top and bottom of the fiber slab, Tt and Tb. So temperature at top is Tt and temperature at bottom is Tb. And what he is saying is Tt is more than Tb. Okay. And there is alpha is the coefficient of thermal expansion, E equals to something like this. Fine. Now unit weight is 0. He is saying unit weight. Warping stresses, why warping stresses will develop? Tt is more than Tb, so it tries to expand. It tries to expand something like this, right? It tries to expand. Fine. If it tries to expand, it tries to expand like this. If there is weight, if weight is acting downwards, then only there will be stresses. But what he is saying, W equals to 0. Unit weight is 0 means indirectly weight is 0. If weight is 0, there won't be any stresses. So warping stresses will be 0. Warping stresses equals to 0. It will just expand. That means if you increase the temperature, top will expand, bottom will compress. Its stresses will not develop. That means it's like free to expand case. In your strength of materials, you might have seen, like let us say, if there is a bar like this, then with increase in temperature, with increase in temperature, delta L will be there. That equals to L alpha delta T. Strain would be equals to delta L upon L. That equals to alpha times delta T. Whereas stress equals to 0. There will not be any stress because it is free to expand. At the same time, let us say if it is fixed. If it is fixed with increase in the temperature by an amount of delta T, what happens is, if it is free, it will expand by this, but since it is not free, it will not expand. So delta L prevented, I'll say, prevented would be equals to L alpha delta T. L alpha delta T. Fine. So the stress that is developed, if they ask, stress developed equals to E alpha delta T. E alpha delta T. Stress will develop because it tries to expand, but fixed support will try to resist. So stresses will be developed here. Strain equals to 0. There is no expansion, so there will be prevention. So strain will be 0, stress will be developed. Here stress is 0, strain will develop. It is free to expand. Same thing over here. Weight is 0. There is nothing to resist, so it will just expand. Simply at top it will expand, top, bottom it will compress. There will not be any resistance, no stresses. So the temperature stresses, if they ask thermal stresses equals to warping stresses plus frictional stresses. Warping stresses plus frictional stresses. Warping stresses plus frictional stresses. This is 0 plus 0, that equals to 0. So the total thermal stresses will be equals to 0. Total thermal stress will be equals to 0. Fine. Any doubts in this? You can ask me. Total thermal stress equals to 0. It just expands. So read the question properly and accordingly attempt the question. Any doubts in this? You can ask me. Any doubts? Any doubts in this? Please go ahead and ask me, guys. Any doubts of how to solve these type of questions? Any doubts? Please go ahead and ask me. If not, I'll go for the next question. If you are having any doubts, please ask me. Please get it cleared right now only. Any doubts? Try to solve this question. The following statements are related to the temperature stresses developed in the concrete pavement slabs with free edges without any restraint. Temperature stresses will be zero during both day and night if the pavement slab is considered as weightless. Temperature stresses will be compressive at bottom of the slab during night time if the self weight of the pavement is considered. So what is the answer? What is the answer for this? What is the answer for this? So your options is, and temperature stresses will be compressive at bottom of the slab during daytime if self weight of the pavement is considered. So the true statement is, what is the true statement he is asking? This is a gate question, I think. Temperature stresses will be zero during both day and night times if pavement slab is considered weightless. That is statement B. Temperature stresses will be compressive at bottom of the slab during night time if self weight of the pavement is considered, and temperature stresses will be compressive at bottom of the slab during daytime if self weight of the pavement is considered. So options, he is asking what is the true statement. So please give me the true statement. What is the true statement out of P, Q, R? What is the true statement? Soumya, what happened to you? You are not there. Kumar, you left? You left? Atul has given the answer. What about the other guys? Please do comment. P and Q true. Yeah, fine. So the idea is very simple. Temperature stresses will be 0 during both day and night times if pavement slab is considered weightless. Right? So this is true. Just now we have seen if pavement is weightless, temperature stresses, here there is no friction. We are talking only about day and night, means that is warping stresses. If it is weightless, if W equals to 0, temperature stresses equals to 0. So this is correct. This is correct. Okay. And temperature stresses will be compressive at the bottom of the slab during night time if self weight is considered. So that means during night time at bottom portion of the slab, what is the temperature stresses he is asking? Fine. During night time at bottom portion of the slab, temperature stresses would be compressive. So this is correct. He has not mentioned corners or anything, so that means you can take it as edges only. Fine. Temperature stresses will be compressive at bottom portion of the slab if weight is considered with free edges without any restraint. Okay. So this is also correct. And what he is saying, during daytime, temperature stresses will be compressive at bottom portion of the slab during daytime if self weight is considered. So during daytime at bottom portion of the slab, temperature stresses is tensile. It is not compressive. So that means this is wrong. This is wrong. So true statements are P and Q only. This is your gate question only. True statements are P and Q. Fine. So this is how you'll try to solve this question. So this is the concept that is related to stresses. Now coming to joints. The major thing in the rigid pavements are joints. There are different types of joints: compression joint, tension joint, expansion joint, compressive joint, contraction joint, and warping joint. Fine. So first of all, if I try to show the slab, joints, generally if you see the joints concept, if let us say this is the direction of the traffic, fine, this is called as longitudinal joint, and this is called these are called as transverse joints. This is called as longitudinal joint, and these are called as transverse joint. So if this is transverse joint, the bars that is provided in transverse joint is called as dowel bars. These are the bars that is effective in taking the load. Fine. These are the bars that is effective in taking the load. So the bars that is provided is called as dowel bars. These bars are called as dowel bars. It is provided in the direction of traffic. This is the direction of traffic. So dowel bars which are effective in taking load. Fine, and it is provided across transverse joints. Joints which are in direction of traffic. Transverse joints are the joints perpendicular to the direction of traffic. Longitudinal joints are joints in the direction of traffic. These are longitudinal joints, and these are transverse joints. And bars that is provided along the longitudinal joints, these are called as tie bars. The major function of tie bars is to hold the blocks together. That's it. It will not transfer any load. Fine. So tie bars provided to hold the blocks together. To hold blocks together will provide tie bars. And these are dowel bars. Dowel bars are the one which is effective in taking the load. Dowel bars are provided in the direction of traffic, whereas tie bars are provided in the direction perpendicular to the traffic. And longitudinal joints are joints in the direction of traffic. Transverse joints are the joints in the direction perpendicular to the traffic. And different types of transverse joints, if you see, expansion joint is a type of transverse joint. Fine. This is a transverse joint only. So expansion joint, if you see, that is provided to take care of the expansion that occurs during the summers. Fine. So this is the expansion joint that is generally provided. Expansion joint that would be generally provided. So this is provided in such a way that even after expansion, a spacing of delta by 2 is maintained. Right. This is delta upon 2. This is delta upon 4. This is also delta upon 4. Okay, this is one of the point. this is delta by 4, delta by 4, delta by 2. So even after expansion, a spacing of delta by 2 has to be maintained, and generally it is provided by filler material. If I take the length as L, length of the slab as L, fine. So generally on this side it is delta by 4, on this side it is delta by 4, so total it is delta by 2, spacing will be delta by 2 should be equals to L alpha delta T, L alpha delta T, where alpha equals to coefficient of thermal expansion, coefficient of thermal expansion, coefficient of thermal expansion, and delta T is the change in the temperature, change in the temperature. L is, you can say this as the length of the slab or spacing between the joints, spacing between the expansion joints, expansion joints, spacing between the expansion joints. Generally L should not be more than 140 meters. L should not be more than 140 meters, and delta delta should not be more than 2.5 centimeters. Delta generally should not be more than, the spacing should not be more than 2.5 centimeters, and length should not be more than 1.5 meters. Expansion joint is provided to take care of the expansion that occurs, fine, during the when these are placed. Expansion joint, this is also type of transverse joint only, fine. Any doubts in this? You can ask me. Any doubts? Delta by 4, delta by 4, delta by 2 equals to L alpha delta T. Delta equals to L alpha delta T. Using that concept only, we'll be doing this. Any doubts in this? You can ask me. Expansion joint. If you are having any doubts, please go ahead and ask me, and please do like, share, subscribe. Any doubts? Sir, in this, if they give like 40% expansion, how will the formula change? If they give like 40% expansion means what? Okay, 40% expansion means on this side it is 0.4 times delta, or 40% expansion means whole expansion. Instead of delta by 2, you will be taking 0.4 times delta, that's it. If it is 40% expansion, you will be taking 0.4 times delta. That's it. Nothing else will change. Here it is 50% expansion. On this side, delta by 4, delta by 4. If it is 40% expansion, then it is 0.4 times delta. 0.4 times delta. Okay, yeah, fine. Now try to solve this question. The width of the expansion joint is 20 mm. The width of the expansion joint is 20 mm in a cement concrete pavement. The laying temperature is 20 degrees. The laying temperature is 20 degrees. Maximum slab temperature is 60 degrees Celsius. The coefficient of thermal expansion is 10 multiplied with 10 to the power of minus 6 mm. That is the coefficient. And the joint filler compresses up to 50% of the thickness. Joint filler compresses up to 50% of the thickness. The spacing between the expansion joints should be. What is the spacing between the expansion joints? Please give me the answer. Spacing between the expansion joints, please give me the answer. 25. What about the other people? What about the other people? Please do. B, 25 meters. Fine. So how you are going to find this out? Width of the expansion joint is 20 mm. Delta is given as 20 mm. Whole delta is given as 20 mm. Just apply. That means if filler is here, whole thing filler will be provided, and what he is saying, filler is compressed by 50%. That means on this side it is delta by 4, delta by 4. Same thing. Just apply this formula. Delta by 2 equals to delta upon 2 alpha delta t would be equals to L. So L would be equals to 20 mm. 20 into 10 to the power of minus 3 upon 2 multiplied with alpha. Alpha is 10 into 10 to the power of minus 6. 10 to the power of minus 6, and delta T, temperature is increased from 20 degrees to 60 degrees. So delta T would be equals to 40 degrees. So 10 to the power of minus 4, 10 to the power of minus 5, 20 into 10 to the power of 5 into 10 to the power of minus 3 upon 2 multiplied with 4. So that is 10 square, 25. Approximately, I think this is the thing, 10 power minus 5, 40. So this is 25 meters. L equals to 25 meters. Convert everything into this. Simple answer, 25 meters. Okay, simple. Fine. Next, this is how you'll try to solve problems in expansion joint. Expansion joint. Okay. Same question. The width of the expansion joint. The width of the expansion joint gap is 2.5 centimeters in a cement concrete pavement. The spacing between the expansion joint for maximum rise of 25 degrees Celsius, assuming alpha equals to 10 into 10 to the power of minus 6. So what is the answer of L? Please give me the answer for L. So you keep on doing it, I'll just come. Atul has given answer as 50. So direct application of formula, delta equals to 2.5 centimeters. So 2.5 into 10 to the power of minus 2 meters, and L would be equals to delta upon 2 alpha delta T, right? So this is 2.5 multiplied with 10 to the power of minus 2 upon 2 multiplied with alpha is how much? Alpha is 10 to the power of minus 5. Directly I'll take this, and delta T is given as 25. So 25, this is 10 to the power of 3, 10 square, 50 meters. So option is B, direct answer. Any doubts in this? Fine, that is what you are getting it. Next, this is expansion joints. Next one is contraction joints. Contraction joints is also transverse joints only. Contraction joints is also transverse joint. And why it is provided? It is provided to take care of shrinkage of the concrete. Provided to take care of shrinkage. Provided to take care of shrinkage of concrete. Provided to take care of shrinkage of concrete. Fine. So it is provided to take care of shrinkage of concrete. And fine. So shrinkage of concrete means stresses that will be developed will be something like this. In this direction the stresses will be developed. Sir, why you are giving us proof? I am not giving you the proof, I am just showing you the diagram, that's it. Okay, don't take it in another way. I am not wasting your time by giving proofs and all those things. I am just showing you how the diagram would be, figure would be. Fine. So this is the contraction joint. It is provided to take care of shrinkage of the concrete. Tries to shrink and it tries to resist. Fine. So this will be shrinkage, contraction joints. And here let us say if no double bars are provided, if no double bars are provided, or if double bars are not provided, if double bars are not provided, if double bars are not provided. So if double bars are not provided, what we can say over here is F multiplied with W, that's how we can write this, right? Or if double bars are not provided, then stress that is developed would be equals to, the stress that is developed would be equals to SF multiplied with B multiplied with H, or SF would be equals to F gamma Lx upon 2. F, just now we have solved that, F gamma Lx upon 2 or L. Fine. Where SF would be equals to SC, ultimate tensile strength of concrete. If I take this as ultimate tensile strength of concrete. Generally it is taken as ultimate tensile strength of concrete. Fine. So if this is SC and F value all we know, generally Lx should not be more than 4.4 meters. That is spacing between spacing between contraction joint, spacing between contraction joint should not be more than 4.5 or 4.4 meters if double bars are not provided. 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 Okay. So this is the idea. And let us say if double bars are provided. Double bars are the bars which will take the load, and that is provided in transverse joint. Contraction joint is also a transverse joint. Fine. If double bars are provided, then stress is taken by, will be taken by, or if double bars are provided, then stress is taken by the steel, right? Let us say this is AST multiplied with sigma ST. AST multiplied with sigma ST. So what you can write over here is the total compressive force is taken by steel, that equals to SF multiplied with B multiplied with H. SF equals to F gamma Lx by 2 multiplied with B multiplied with H, that equals to AST multiplied with sigma ST. From this, Lx would be equals to 2 AST sigma ST upon F gamma B H. This is how you calculate spacing between the contraction joints. Spacing between the contraction joints. If double bars are provided, spacing between the contraction joints is calculated something like this. I am directly giving you the formula. You can remember or you can prove. It's up to you. Fine. So this is how you calculate spacing between the contraction joints if double bars are provided, and if double bars are not provided, spacing between the contraction joint is something like this. Lx equals to 2 SF upon F gamma. Lx would be equals to 2 SF upon F gamma. Generally F value would be 1.5 and this is 24 kilonewton per meter cube. Fine. Accordingly, you'll get the answer. SF would be 0.8 kgs per centimeter square. You can change it and get the answers in whatever the way you want. Fine. So this is how you have to find out. This is contraction joint. Now once if you know expansion joint and contraction joint, other types of transverse joints would be constriction joint and warping joint. Constriction joint. So constriction joint, it's like during constructions, like it's already 5 o'clock, the people will say will not work, so automatically they leave the work and they'll go, automatically some extra joints will be formed. So what you will be doing is, you'll ask them if to stop the work either at expansion joint or contraction joint, okay, so that the extra joints cannot be formed. Joints are the weakest locations. Fine, because at the joints there will not be anything, so the failure can be more at the joint, so you have to be more critical while doing the joints. Fine. Other type of joints is warping joints. Warping joints are provided to take care of warping stresses. That's it. It is same as that of the contraction joint only, but another name is given to that. Warping joints, that is provided to take care of the warping stresses. These are the different types of joints that we generally see. Expansion, contraction, constriction, warping joints. Fine. Next we'll see tie bars. So why tie bars? Tie bars are provided to hold the blocks together. Tie bars are provided to hold the blocks. Tie bars are provided to hold the blocks together. There is no any functional use because of tie bars, and this is provided in the direction of traffic, provided perpendicular to the direction of traffic, and along longitudinal joints, right? Along longitudinal joints. Next, if that is the case, generally if you see tie bars, how you are going to design the tie bar. I will be discussing design of tie bar but not double bars, because that is not important from the gate point of view. Okay, so if let us say this is B, it is provided along the longitudinal joints, not transverse joint. So along the width you will be seeing like this. This is B, and for 1 meter length, if I talk for 1 meter length, and height is H, if let us say the height is H, and this is SF, okay, I will take this as some stresses, SF, and tie bars are provided somewhere here. tie bars are provided somewhere here. If I say that, so if this is the tie bars are provided somewhere here. The force or is taken by tie bar. So AST multiplied with sigma ST equals to SF multiplied with here I am talking for 1 meter length, 1 multiplied with H. So SF multiplied with 1 multiplied with H, and this is equals to F gamma B. Instead of Lx by 2, it is B over here. So B multiplied with 1 multiplied with H, that equals to AST multiplied with sigma ST. So finally AST, the steel that has to be provided, if you calculate F gamma BH upon sigma ST. This is for 1 meter length. AST for 1 meter length. This is how you'll try to find out the tie bars. And spacing of the bars is generally given as 1000 multiplied with small ast upon capital AST. Fine. Spacing generally should not be more than 75 centimeters. And dia of the tie bar is generally taken as 20 mm. Dia of the tie bar is generally taken as 20 mm. So AST is calculated like this, dia of the tie bar is calculated like this. And if they ask what is the length of the tie bar, it is calculated based on development length concept. Fine. So let us say there is a tie bar that is provided something like this, and tensile force is being applied over here, and this one is called as development length, LD. LD is the development length. On this there will be bond strength, tau BD, right? Tau BD. So tau BD multiplied with LD multiplied with pi times phi equals to T. T, that would be equals to sigma multiplied with AST is pi by 4 multiplied with phi square. So pi gets cancelled. LD would be equals to phi times sigma ST multiplied with 4 tau BD. This is the development length. If they ask what is the length of the tie bar, would be, this is LD and this is also LD. So length of tie bar would be equals to 2 times LD. Length of tie bar would be equals to 2 times LD. So what I can write over here is L equals to 2 times LD, 2 times phi multiplied with sigma ST multiplied with 4 times tau BD. Directly, if they ask what is the length of tie bar, if you remember the formula, it would be easy for you. L would be equals to phi times sigma ST upon 2 tau BD. Phi times sigma ST upon 2 tau BD. Length of tie bar equals to phi times sigma ST upon 2 tau BD. This is the length of tie bar, and dia AST will be calculating like this. Dia of the tie bar generally it is taken 20 mm, and spacing should not be more than 75 centimeters. Fine. So any doubts in this, you can ask me. Any doubts in this? Please do. The likes are also not increasing today. Please do like, share, subscribe. I don't know, number of people should have been increased. There are 9 people watching and only 3 people are commenting. What about the other guys? Phi sigma ST upon 2 tau BD. Any doubts in this? If anyone is there, please do comment. Please do comment. Please do comment. If anyone is there, please do comment. No doubts? Yeah, fine. Let's try to solve a problem on this. I think there is a problem which was asked in the gate. So the question that will be given to you is tie bars of 12 mm diameter. Tie bars of 12 mm diameter are to be provided in a concrete pavement slab. Tie bars of 12 mm diameter are to be provided in a concrete pavement slab. The working tensile stress of the tie bar is 230 megapascals. The average bond strength between the tie bar and concrete is 2 MPa, and the joint gap between the slabs is 10 mm. Ignoring the loss of bond and tolerance factor, the design length of tie bars. He is asking what is the design length of tie bar. Please try to find out what is the design length of tie bar. Please tell me weightage of rigid pavement, sir. See, it's not like weightage of rigid pavement. You can't say that. You can get 2 marks from here. See, transportation is for 6 to 8 marks. Generally, the ideology will be like this: 2 marks from uh, you know geometric design of highways, 2 marks from traffic, 2 marks from rigid pavement. So 6, and 2 marks from railways and airport, 8, 6 to 8 marks. So that's how the logic goes. And sir, why can't I remove this? See, there are 2 sessions, morning session and evening session. I don't know in which session you will be, but definitely that it's like 8 plus 8, 16 marks. They'll cover all the concepts here. In the morning session, if you don't find a problem on rigid pavement, in the evening session you'll find a problem on rigid pavement. In morning session, if there is no problem on airport, in evening session there might be a problem of airport. So you don't know which comes where. That is the reason I am discussing all these things. If you don't want me to discuss, I won't discuss. Not a bigger issue. Why I am discussing this is, anyway I have given the whole day for transportation. That's why I am discussing. By evening 6 or by 7, we'll try to complete the transportation and we'll go for the next subject. Or Soumya, if you're not understanding rigid pavement, let me know. I'll try to explain in somewhat detail. Not, it takes another 5 minutes. Tie bars and dowel bars, or any doubts? So tie bars of 12 mm diameter are provided in a concrete pavement slab. So length of the tie bar, what he is saying is, generally if you see the slab, there will be slab here and there will be slab here, right? So tie bar would be this one. This is the tie bar that will be provided. Fine. And from here to here, length is LD, and from here to here, length is another LD. LD. I have given directly 2 times LD, but see here, he has specified this gap also. This gap is given as 10 mm. So total length of tie bar would be equals to 2 times LD plus 10, right? That is the basic understanding you have to give. 2 times LD plus 10. Gap is 10 mm. So LD would be equals to how much? 5 times sigma ST multiplied with 4 tau BD. So phi equals to 12 mm, sigma ST is 230 Newton per mm square upon 4 tau BD. Tau BD is how much? 2 MPa. This is 2. So 2, 6, 3 2s or 2 3s, 2 2s, 2, 1, 1, 5. So that would be equals to 230 multiplied with 3, 690, 690. So this is LD would be equals to 3 into 230 by 2. We'll keep it like this, 690 upon 2. So if I substitute over here, 690 plus 10, that equals to 700 mm. Length of tie bar is 700 mm. Good afternoon, Prachi. Tolerance factor means where have you seen the tolerance factor? Which tolerance factor you are talking about, Atul? Tolerance factor that we generally see in the RCC because if you want me to take, I'll take. Formula somewhat difficult to remember. See, you don't have to remember that stresses due to wheel load, stresses due to warping stresses. Just remember stresses due to frictional stresses. I think that would be easy for you. Okay. If you want hydrology, if everyone wants that, I'll take Prachi, not a bigger issue. Tolerance factor is something like, how much it is effective in tolerating the load. This, because of tolerance factor, there will be somewhat expansion or contraction. Anyway, that factor is not given over here. We are not considering it. Okay. That is the meaning of it. Loss of bond and tolerance factor. Any doubts, guys? Any doubts? If you're having basic doubts also, you can ask me. We can go for the next session or next points in this. Okay, fine. Next one is dowel bars. Dowel bars are provided along the transverse joint. Dowel bars are provided along the transverse joint. I will not be designing the dowel bars here, but I will be just showing it. So dowel bars are provided for what cause? Dowel bars are provided if, let us say, this is a dowel bar. Fine. Why dowel bars are provided? First one is to transfer the load. When load is being applied over here, it will transfer the load from this slab to this slab. So transfer of load. Transfer of load. Dowel bars are provided for transfer of load. Next one is settlement. If there is only this one, there will be huge amount of settlement. Because of providing, there will be settlement in this delta. There will not be any settlement in this. If dowel bar is not there, there will be huge amount of settlement in this, and there will be no settlement in this. And if dowel bar is provided, then settlement will be reduced. So that means differential settlement will be reduced. Differential settlement will be reduced. Differential settlement will be reduced. Differential settlement would be reduced. Generally, dia of the dowel bar is greater than 25 mm. You will provide a dia of dowel bar greater than 25 mm. And spacing of the dowel bars, minimum spacing of dowel bars, equals to 200 mm for 15 centimeters thick slab, and 300 mm for 20 centimeters thick slab, Okay, this is the spacing of the dowel bars. These are some of the points in the dowel bars, and it is provided in the transverse joint, and it is provided along the direction of traffic. Provided along the direction of traffic. Provided along the direction of traffic. At transverse joints. Fine. So these are the points that you have to generally remember from this point of view. Next, what we'll be seeing in this is overlays. Thickness of overlay. Thickness of overlays that means flexible pavement over flexible overlay over flexible pavement, bituminous over flexible overlay over rigid pavement, rigid overlay over rigid pavement, and rigid overlay over flexible pavement. These are the different types of overlays. Dowel bars in concrete pavement are placed Double bars in concrete pavement are placed along the direction of the traffic. Tie bars are placed in the direction perpendicular to the traffic. Okay, so if they ask double bars are placed along the direction of the traffic, tie bars are placed in the direction perpendicular to the traffic. Fine. So that is the point that we have to generally see. Anyway, so thickness of overlay. If they ask thickness of overlay, thickness of overlay, there are different types of overlays. Flexible overlay over flexible pavement, flexible overlay over flexible pavement, over flexible pavement, over flexible pavement, rigid overlay or flexible overlay over rigid pavement, flexible overlay over rigid pavement, or rigid pavement, and flexible rigid overlay over flexible pavement, rigid overlay over flexible pavement, over flexible pavement, and rigid overlay over rigid pavement, rigid overlay over rigid pavement, over rigid pavement. So these are the different types of overlays that you should generally consider. Fine. So if at all I take a pavement, pavement and an extra overlay thickness is provided. Why, sir? Why on the cement concrete pavement an extra thickness is provided? Why? Because it will become flexible. That is the idea. We get the advantages of both flexible as well as rigid. Okay. If H is the thickness, H naught is the overlay thickness. H naught is the thickness of overlay. This is thickness of overlay. Thickness of overlay. So this is found out by using Benkelman beam test. Benkelman beam test. Benkelman beam test. Fine. So Benkelman beam test, what exactly is happening in the Benkelman beam test would be, first we'll try to find out mean of, what he'll be doing is he'll be allowing the vehicle to pass on this. He'll try to measure the deflections at different directions, at different locations. He's trying to find out the mean deflection. So mean deflection delta is generally given as delta equals to sigma I runs from 1 to n di upon n. That is mean deflection. Sigma I runs from 1 to n di upon n. This is mean deflection. Fine. Next, characteristic deflection. Characteristic deflection. If they ask characteristic deflection DC, characteristic deflection DC equals to delta plus x times sigma. Delta plus x times sigma. X is a factor that will be given to you. If not, they'll say delta plus 2 times sigma, where sigma is the standard deviation. Sigma is the standard deviation. Sigma is the standard deviation, generally given as under root of, or anyway, you are not going to calculate over here. This is the standard deviation. Fine. This is characteristic deflection, and this has to be corrected for temperature. Correction due to temperature. Correction due to temperature. dt would be equals to dc minus 0.0035 multiplied with T minus 15. So this is correction due to temperature. This will be correction due to temperature. Next, correction due to moisture. Correction due to moisture. So correction due to subgrade moisture. Subgrade moisture, that will be given to you in the question anyway. So DCC, I'll call this as dcc. That would be equals to 1.2 to 1.3 times dt if it is clay soil, and that would be equals to 2 times dt if it is sandy soil. Fine. So this is called characteristic corrected deflection. Characteristic corrected deflection. Characteristic corrected deflection. And now H naught would be generally given as 550 times dcc upon dA. 550 times log dcc upon dA. dcc upon dA. Fine. Where dA is the allowable deflection. This will be generally given in centimeters. Okay. So dA is the allowable deflection. dA equals to allowable deflection. Allowable deflection, that will be given to you in the question. Fine. So it depends upon the traffic volume. Traffic flow or traffic volume. Traffic flow dA. If it is in the range of 1500 to 4500 vehicles per hour, then dA is 1 mm. And if it is in the range of 450 to 1500 vehicles per hour, dA is 1.25 mm. And if it is in the range of 150 to 450 vehicles per hour, dA is in the range of 1.5 mm. Fine. So anyway, you don't have to remember this. This will be given to you in the question. From here, you will try to find out what is the overlay thickness. What is the overlay thickness that should be provided. Fine. So first you have to, mean will be given to you, and this x value will be given to you, standard deviation will be given to you. You will calculate characteristic deflection, you will correct it for temperature, you will correct it for moisture, and then finally you will get mean deflection. Double bars are provided in expansion and contraction joint. I said double bars are provided in transverse joints. So transverse joints, generally at expansion joint filler material will be provided. In contraction joint double bars will be provided. You have to read the go through the class. I am in the other mode right now. Okay. So this is the idea. Now if bituminous concrete is used as an overlay, if bituminous concrete is used as an overlay, if bituminous concrete is used as an overlay, then a factor of 2 would be used. Then means H naught would be equals to H naught by 2. H naught final would be equals to whatever the H naught is used, H naught upon 2. A factor of 2 would be used. Read the question properly. If bituminous concrete is used in overlay, then you will be using a factor of 2 over there. H naught final would be equals to HO upon 2. Fine. So this is how you will try to find out the overlay thickness. Any doubts in this? You can ask me. Any doubts? Please do comment. Please do comment if you are having any doubts. sorry, please change this, and the units for this one is also mm. Units for this one is also mm. Okay, please change it, and I'm sorry, I have given something wrong. Please try to change it. Please change it. 0.0065, not 35, it is 65 t minus 35. Fine. Okay, so according to IRC 3058 2018, this is the idea. Anyway, so this is how we try to find out thickness of overlay, and I think there was a problem on this. I don't think, no, there is a problem on this. Fine. So these are the major things that we generally see in the design of pavements. It's okay, guys, so there is no question regarding that, but anyway, if the question is given to you, you'll try to solve in that fashion. Fine. So with this, I'm closing this session in the sense we'll take lunch break, because if I start highway materials, I'll not be able to complete it on time. So after the lunch, maybe by 2:30 or 2:45, 1 hour we'll take the lunch break, and after the lunch break we'll try to solve what are the things. Highway materials is left over, and railways, airport, everything will be completed in the afternoon session only, because according to the problems we'll go. Okay, so I hope I took some amount of your time, like 8 hours I took yesterday morning, 4 hours to 5 hours. I'm taking it from 9, right? 4 hours to 5 hours I have taken, but it is worth. At least you will be getting 4 to 5, 4 marks definitely you will get from this. You can score from whatever I have studied. You have studied from me. If you are confident about it, you can easily score 4 marks. Next, in the evening, we'll try to get another 2 marks, and 2 marks out of 8 marks you can score easily 6 marks. If you are lucky enough, you can score 8. And if there is some new question, we can't do anything. You have to, if there is any theoretical question or new question, you just have to leave it. Okay, so we'll take a break, and then we'll meet by 2:40 or 3. Okay. Hi friends, are you there? I think we took some decent amount of break. It's okay. Obviously, 1 hour of break is enough, right? I mean, in the sense, 1 hour. I think we need 1 hour of break because if we constantly keep on studying, also, I don't think so. That would be a good idea. But anyway, it depends upon an individual. Some people like to study continuously. Some people like to take breaks in between. So it depends upon the individual. Fine. So good afternoon, sir. Good afternoon, Bhaskar sir. How are you? And whoever 7 people are watching now. I don't know who are the 7 to 8 people here. Constantly from morning, Atul and Saumya is giving me the answers. What about the other guys? Other 7 people? Who are they? They are constantly present, but uh, they are not, commenting. Good afternoon, Saumya. So Saumya is one that girl who is there, and who are the other guys? Please do comment, guys. Please do comment. Who are the other people? Please comment. You're not going to comment? Just say hi, no issues. Atul, I don't think so. Atul is there right now. I think he might have left, thinking that his work is done over here. And if there are any other people, please do comment, or I'll start the class. We'll discuss highway materials. So next take please EE class, sir, environmental engineering. Any idea who dealt it in Gate CEME channel? Because I don't know, I have to ask Amit sir regarding that. I'll ask them and I'll get back to you whether I can take environmental engineering or not. And Prachi has asked for hydrology. If I have to take EE, will itself will take 3 days here. I'm sure about that. Environmental engineering continuously, if I have to take, it will take 3 days. 3 days for that. If you want me to take, I'll take EE, or if 3 small subjects also fine with me. Anything for you. Exactly, there are 7 people watching, so the rest of the 5 people can comment, right? So who are the other guys? Please comment. If there is one more person, I'll start the class. Okay, so then 3 small subjects better. I'll study myself. You have to take a stance. Then what are those 3 small subjects that you want me to discuss? Hydrology, she asked me to discuss, so I can discuss hydrology. And water resource engineering, yeah, that is irrigation. One day should be enough for both the things, because I'm discussing only questions. And what are the other subjects? RCC, I think SAR is dealing right now. Anyway, I'll take the class. Can I take the class? So I think only Saumya is present. I don't know who are the other 6 to 7 people over there. Fine. So Saumya, fine. Assuming that I don't have to teach the theory here, highway materials is more of theory, and I'll not teach the theory. I'll keep on doing the problems in between. Whenever a question comes, I'll try to explain it. Okay. So Fine. So highway materials, what are the different types of highway materials that we generally see? Different types of highway materials. Here, if we talk about highway materials, we are talking about two things, that is aggregates and bitumen. Kumar, I don't think so. Nobody is taking RCC in global. I'll ask sir whether I can take RCC or not. Fine. So, what is that? Yeah, highway materials. Two things that you have to remember in highway materials. Highway materials. So, in highway materials, majorly we have to be worried about aggregates and bitumen, because aggregates and bitumen. Aggregates, bitumen. Aggregates and bitumen. In aggregates, there will be further two things: coarse aggregates, fine aggregates. Fine aggregates means indirectly that is soil, sieve analysis. In your geotechnical engineering, you will discuss everything over there. And coarse aggregates. Coarse aggregates is what that we are going to discuss. Coarse aggregates and bitumen. Fine. So in coarse aggregates, the different things that you have to remember. First one is compressive strength of coarse aggregates. Compressive strength. Compressive strength of coarse aggregates. Compressive strength of coarse aggregates. Compressive strength of coarse aggregates is measured by a test. Which is called as aggregate crushing value test. Aggregate crushing value test. Aggregate crushing value test. Aggregate crushing value test. Fine. So here generally what we take is, we take in a beaker or in the machine, we'll take aggregates passing through 12 mm sieve. So there are certain aggregates that we'll take passing through 12 mm sieve and retained on 10 mm sieve. Okay. So aggregates passing through 12 mm sieve, aggregates passing through 12.5 mm sieve and retained on 10 mm sieve. Fine. So we'll take aggregates passing through 12.5 mm. That type of aggregates we'll take, and we'll apply the load on it constantly, 40 tons load, 4 tons per minute. 4 tons per minute. For 10 minutes you will apply the load, so that 40 tons load will apply on it. Once you apply the load, after that you will take the aggregates and you will pass the aggregates to 2.36 mm sieve. 2.36 mm sieve. So aggregate crushing value. Aggregate crushing value is generally given as weight of the aggregates passing through, weight of the aggregates passing through 2.36 mm sieve, weight of the aggregates passing through 2.36 mm sieve, 2.36 mm sieve upon total weight of the aggregates, total weight of the aggregates, total weight of the aggregates, total weight of the aggregates. Fine. And ACV should not be more than 30% for surface course, and it should not be more than 45% for base course. Aggregate crushing value should not be more than something like this. So this is aggregate crushing value test. In aggregate crushing value test, we are going to measure the compressive strength of the aggregates. Fine. Aggregate crushing value test, compressive strength of the test. Fine. Next one, aggregate impact value test. Aggregate impact value. Aggregate impact value. So we are going to find toughness from this test. aggregate impact value, toughness from this test. It is also weight of aggregates passing through 2.36 mm sieve, weight of aggregates passing through 2.36 mm sieve upon total weight of aggregates, whole thing upon total weight of aggregates, whole thing upon total weight of aggregates. Fine. This is aggregate impact value. From aggregate impact value, we are going to find out the toughness of the aggregates, and that is measured like, if what we'll be doing is same thing. We'll take some amount of aggregates passing through 2.5 mm sieve, 12.5 mm sieve, and retained on 10 mm sieve. You'll take aggregates, you'll pass through 12.5 mm sieve and retained on 10 mm sieve. You'll take some amount of aggregates over here. Fine. So here you'll take some amount of aggregates, and then you'll release the hammer of weight 13.5 kgs to 14.5 kgs, 13.5 kgs to 14.5 kgs from a height of 38 centimeters, and you'll provide 15 number of blows, 15 blows. So here what we are measuring resistance to impact. Fine. We are measuring resistance to the impact. So aggregate impact value is, once if you allow it to fall for 15 blows, then you'll try to pass this through 2.36 mm sieve. You'll try to pass this through 2.36 mm sieve, and weight of the aggregates passing through 2.36 mm sieve upon total weight of the aggregates. That is aggregate impact value, and aggregate impact value should not be more than 30% for surface course, and it should not be more than 35% for base course, sometimes 45% also. Fine. This is the idea. This is from aggregate impact value. We are going to measure resistance to the impact, that is toughness. Next, here strength you are going to measure by aggregate crushing value, toughness you will be measuring by aggregate impact value, and then next one is Los Angeles abrasion test. Los Angeles abrasion test. Los Angeles abrasion test. So by this you are going to measure hardness of the aggregates, hardness, comma, resistance to wear and tear, resistance to wear and tear. So here what you will be doing is, you will be taking a steel drum, and you will be rotating it at the rate of 33 revolutions per minute for 500 revolutions. You will keep on rotating it for 33 rotations or revolutions per minute for 500 revolutions. Fine. So this is one of the thing. So you'll keep on rotating it. In this, you'll be there will be aggregates and there will be steel balls. There will be aggregates and there will be steel balls also. So here, what you will be doing is, you are going to measure the resistance to wear and tear. Like wheels sometimes will be made up of steel. So when that steel comes in contact with the aggregates, what happens? There will be wearing of the aggregates, and it can tear also. We are going to measure it something like this. Fine. After that, you will pass this through 1.7 mm sieve. So hardness is measured by Los Angeles abrasion value. So that is generally given as weight of aggregates passing through 1.7 mm sieve. Here it is 1.7 mm, not upon total weight of aggregates. Fine. fine. And this value same, 30% for surface course, 30% for surface, it should not be more than 30% for surface course, and it should not be more than 45% for base course. Same thing, 45% for base course. So this is one of the best tests. Los Angeles aberration value test is one of the best tests to find out the wear and tear of the aggregates and all the other things. Fine. Next point, Los Angeles aberration value test, aggregate crushing value, aggregate impact value, Los Angeles aberration value test. Fine. Next one is soundness test. Soundness means we are not going to measure the sound of it, we are going to measure the durability of the aggregates when it is subjected to different weathering action. So durability of aggregates is measured by soundness test. Durability of aggregates is measured by soundness test. So what you will be doing is, durability means once if it is different weathering actions, because aggregates are subjected to different chemicals. So what is the change, what is the loss of the weight, that we will be seeing. So for this what we will be doing is, we'll make a mold of aggregates, we'll try to immerse that in sodium sulfate solution or magnesium sulfate solution, MgSO4. Fine. You'll immerse it and you'll heat it. After that you'll heat it. Fine. So once if you heat it, the percentage loss of weight of aggregates, percentage loss of weight of aggregates should not be more than 12% here, and percentage loss of weight of aggregates should not be more than 18% here. Fine. So that is soundness test. Durability means resistance to weathering action. Percentage loss of weight of aggregate should not be more than 12%, and percentage loss of weight of aggregate should not be more than 18% here. Fine. So this is resistance to this is durability. Fine. Next, soundness test. Specific gravity test, you know that you can calculate that from pycnometer. Fine. Specific gravity test, you can calculate that from pycnometer method, which you might have seen in your geotechnical engineering. I am not discussing that. What is specific gravity? Unit weight of the material of given volume, unit weight of material of given volume, unit weight of the material of given volume upon unit weight of the standard fluid of same volume. Unit weight of standard fluid of same volume. So G value will be generally in the range of 2.5 to 2.9. Fine. Next, shape of the aggregates. Shape of the aggregates is also one of the important parameter. Shape of the aggregates. So what are the different types or different shapes of the aggregates that you'll generally find? We can find round aggregates. We generally find round, angular, flaky, thickness is less, flaky, and elongated, length is more. Fine. So round aggregates, angular aggregates, flaky particles, and elongated particles. Flaky particles and elongated particles, right? Flaky particles and elongated particles. For round aggregates, area of lubrication is very less, so workability is more for this. Workability workability is more in round aggregates. Area of lubrication, that means when you apply the cement or bitumen over here, the area of lubrication is very less, so workability will be more here. And here in angular aggregates, interlocking between the aggregates will be more. So interlocking between the aggregates, if it is more, then strength obtained from here will be high. Strength will be more. Strength will be more. Since interlocking between the aggregates is high, strength will be more. Flaky particles and elongated particles, you will neither get workability nor strength. So our idea is to avoid flaky particles and elongated particles. So for finding out flaky particles, what you will be doing is flakiness index test you have to do. Flakiness index test. Flakiness index test for finding out elongated flaky particles, you have to do flakiness index test. So a particle is said to be flaky if its minimum size, inertly thickness, should be less than 0.6 times mean size L plus B by 2. So if it is minimum size is less than 0.6 times mean size, then particle is said to be flaky particle. Particle is said to be flaky particle, and this is measured by using thickness gauge. By using thickness gauge. So how exactly the thickness gauge looks like? If I have to, I'm just showing it in a simplest way. So here there will be some small gaps and everything. It looks something like this. And flakiness index is applicable for particles more than 6.3 mm size. It is not applicable for particles less than 6.3 mm size. So what you will be, let us say this hole is 6.3 mm to 10 mm. You will take the aggregates, you will try to pass through this. So if it is passing through this, its thickness is less. If it is not passing through this, then its thickness is more. Fine. So flakiness index, what I will say is weight of the particles passing through thickness gauge, weight of the particles passing through thickness gauge, weight of the particles passing through thickness gauge upon total weight of the particles, upon total weight of the particles, upon total weight of the particles, upon total weight of the particles. That is flakiness index, and flakiness index should not be more than 15%. Flakiness index should not be more than 15%. So if it is passing through this hole, that means thickness is less. If it is retained, then thickness is more. Then it's a good particle. That is flakiness index. Next one is elongation index. Elongation index. So elongation index. Elongation index. Fine. So if you see elongation index, if maximum size or if length is more than 1.8 times mean size, if maximum size is more than 1.8 times mean size, that is b plus t upon 2, or maximum size of particle, if maximum size is more than 1.8 times mean size of particle, mean size, then it is known as elongation. The particle is known as elongated particle. The particle is known as elongated particle. So this is measured by using an instrument called length gauge. This is measured by using an instrument called length gauge. It looks something like this. It looks something like this. So what happens is, you'll take the particles and you'll try to pass through this aperture. If it passes through this, length is less. If it is retained on this, length will be more. Fine. You'll take a particle, you try to pass through this. If it passes through this, it's okay. If it doesn't pass through this, it is retained, then it is called as elongated particle. Fine. So this is a length gauge. This is called as length gauge. gauge. This is called as length gauge. Okay, so since this is length gauge, and elongation index is generally given as weight of the particles, weight of the particles, weight of the particles retained, weight of the particles retained on the length gauge, weight of the particles retained on the length gauge, weight of the particles retained on the length gauge upon total weight of the particles, upon total weight of the particles, total weight of the particles, weight of the particles retained upon length gauge upon total weight of the particles is called as elongation index, and it should not be more than 15%. It should not be more than 15%. So this is how, here it is retained, and there in flakiness index it is passing through it. Fine. So that is the idea, elongation index test. Next, angularity number. Angularity number. Angularity number is generally varies from, angularity number generally varies from 0 to 11. Fine. If angularity number is 0 means rounded aggregates. Rounded aggregates. If angularity number is more than 0, then it is considered as angular aggregate only. Generally it varies from 0 to 11. Angularity number 0 means percentage of voids. If I am saying angularity number is 0, then percentage of voids, if you are taking aggregates in the mold, in a mold if you are taking the aggregates, and if it is perfectly rounded, if aggregates are perfectly rounded, the percentage of voids, percentage of volume of voids equals to 33%. That means percentage of volume of solids would be 67%. If percentage of volume of voids is 33%, angularity number is, angularity number equals to 0. If it is 34%, angularity number is 1. That means if percentage of voids equals to 44%, then angularity number equals to 11. Angularity number equals to 11. So whenever a question is given to you, just try to find out what is the percentage of voids. Percentage of voids is equals to volume of voids upon total volume multiplied with 100. Or this can also be written as total volume minus volume of solids upon total volume multiplied with 100. Fine. So based on that, you will get the angularity number of different particles. Okay. So this is how you are going to find out the shape of the aggregates. That is another property of the highway material, shape of the aggregates. Once you get the shape of the aggregates, fine. So we have seen the shape of the aggregates, and other one is stripping value test. Stripping value. So stripping value, generally it should not be more than 5%. What exactly stripping value is? If you are taking an aggregate, so bitumen should get adhered to it properly. On the top of the surface, bitumen should get adhered to it properly. If it is dry, if the aggregate is dry, when you apply the bitumen, automatically whole surface will get adhered by the bitumen. If not, if there are any wet patches, bitumen will not get adhered. Some part will not be, bitumen will not be there in some part. So how you are going to find out stripping value? Stripping value, it's like we are going to measure the whether bitumen is present throughout the surface or not. Fine. So stripping value is calculated as amount of bitumen. It's not amount of bitumen. So area of the aggregates, area of the aggregate without bitumen upon total area of the aggregates, whole thing upon total area of the aggregate, total area of the aggregate upon total area of the aggregate. Fine. So this is stripping value test. Stripping value should not be more than 5%. Fine. So this point you have to remember. So I think in the afternoon people are sleeping. That's the reason more people are not there. In the morning and evening people are there. In the afternoon people likes to sleep. So if you are sleeping, how will you write your gate examination, that is from 2 to 5? So if your examination is from 2 to 5, then you have to practice yourself to be awake during this time. If you constantly sleep at this point of time during the examination, you can't be awake, right? So think about it. These are the different types of tests that we generally apply on the aggregates. I haven't talked about bitumen over here. I'm talking only about the aggregates. So there is a list. Hardness, you have to match these two things. So hardness of the aggregates. You get the hardness of the aggregates from which test? Abrasion test. Hardness of the aggregates is obtained from abrasion test. Porosity, let us say you don't know that. Toughness, you'll get from impact test. Durability from soundness test. So porosity you'll get from water absorption test. Generally moisture content should not be more than 0.1 to 2%. Okay, that is water absorption test. If you miss that in the water, if you miss the aggregates in the water for high amount of time, so it should not be something like this. So it is 4, 1, 2, 3. Simple. Yeah, Soumya, I gave the answer. That's it. So crushing test is used for what? Crushing test is used for strength. Los Angeles abrasion, hardness. Soundness, weathering. Angularity number, shape. Right? Simple question. Angularity number, shape. Aggregate impact value indicates which one of the following properties of aggregates. Aggregate impact value indicates what? Aggregate impact value indicates toughness. Aggregate impact value indicates toughness. Yeah, aggregate impact value indicates what? Toughness. Simple. Next, generally what is the sequence? Sequence, you'll know first you'll do flakiness index followed by the elongation index on the whole sample. First you'll do flakiness index, then you'll be followed by the elongation test on non-flaky particles. Okay, why? Because first what you do is you take the particles, you pass through the thickness gauge, all the small particles will be removed, bigger particles will present. That particles you'll take for the elongation test, their huge bigger particles will be removed, correct medium particles you will take. So flakiness index followed by the elongation index test is the correct procedure. Flakiness index test followed by the elongation index test on the non-flaky particles, that is your correct procedure. Fine. So this is how you'll try to do this. Maximum questions will be of this nature only. Resistance to impact, toughness, and resistance to wear, hardness, resistance to weathering action, soundness, resistance to crushing, strength. 3142, resistance to strength, crushing. Right? So these are very basic questions will be asked from your properties of highway material. Fine. So properties of aggregates, very basic questions are asked. Next comes an important thing, that is bitumen. Fine. So Bitumen. Why bitumen is used? Why bitumen is used? First thing, bitumen has same property as that of cement. One thing is it has got full binding properties. Second thing is water resisting properties. Bitumen is used because you can use many things, but why? First thing is water should not enter. If water enters, there is problem of mud pumping, frost action, and all those things will be there. So idea is water should not enter into the road. So it should resist the water. At the same time, it should not it should bind all the aggregates and make them act as a single unit. So bitumen is used because it has binding property and water resisting property. Water resisting property. Water resisting property. Fine. That is the reason we will be using bitumen, and tar also has the same thing. We will be using bitumen. Fine. Anyway, so if you see the difference between bitumen and tar, if you have to see the difference between bitumen and tar, so bitumen is obtained by fractional distillation of petroleum. Bitumen is obtained by fractional distillation of petroleum. Fractional distillation of petroleum. Bitumen is obtained by fractional distillation of petroleum. Tar is obtained by destructive distillation of bitumen is obtained by fractional distillation of petroleum. Tar is obtained by destructive distillation of coal or wood. And bitumen, this is soluble in carbon disulfide and carbon tetrachloride. This is soluble in toluene. Fine. These are the major things. And G value is generally, specific gravity is generally 1.02, or sometimes it is more than 1 actually, 1.02 to 1.2. You can take this as approximately 1.2 also, whereas here specific gravity will be in the range of 0.97 to 1.02. That means bitumen can float in the water. This is less temperature susceptible. That means it is not that much effective with the property does not varies with respect to, for small change in temperature there will not be much change in bitumen, but this is more temperature susceptible. So, and here high resistance to water, high resistance to water, and low resistance to water. Tars are generally soft. Bitumen is hard. Compared to that of tar, bitumen is generally hard. Okay, so these are the points that you have to generally remember. And bitumen, there is asphalt bitumen, there is cutback bitumen, and there is emulsions, different types of things you will see. Asphalt bitumen means bitumen with inert material. Is considered as asphalt bitumen. Cutback bitumen is bitumen with volatile dilutants. That is provided to reduce the viscosity. In order to reduce the viscosity, some volatile dilutants will be added. That is cutback bitumen. Emulsions Emulsions means bitumen suspended in the water is considered as emulsions. Bitumen suspended in water. Bitumen suspended in water is known as emulsions. Is known as emulsions. There are different types of things in this, but anyway I'm not discussing it over here, just giving you the basic idea. Bitumen that is suspended in the water is considered as emulsions. Cutback bitumen, bitumen with volatile dilutants. Why volatile dilutants is added? In order to reduce the viscosity. Viscosity should be reduced. Fine. Next, bitumen with inert material is considered as asphalt bitumen. These are some of the points. Next, coming to tests on the bitumen, the first test would be penetration test. Penetration test. Penetration test. So, why penetration test is done? Penetration test is done to find out the grade of the bitumen. Grade of bitumen. Grade of bitumen, or it is indirectly done to measure the softness of the bitumen. Softness of bitumen. Penetration test is not applicable for tar, but it is applicable for bitumen, because tars are very soft. You can't do the penetration test, but for bitumen you can do the penetration test. So in this, what you will be doing is, you will be taking bitumen in a mold and you will try to pass a needle carrying certain amount of weight. Let us say 100 grams of weight. So what happens is, there is a mass of 100 grams on it, and you'll just apply something, you release the needle and it passes through it. It passes through the bitumen. The depth of penetration will give you the penetration value. If let us say penetration value is 80, penetration value is 80. That means depth of penetration is 8 mm. Depth of penetration is 8 mm. Generally, the test is done at room temperature of 25 degrees Celsius. Fine. So, if I say grade of the bitumen, as 80 by 100. If the grade of bitumen is given as 80 upon 100, that means depth of penetration is in the range of depth of penetration is in the range of 8 mm to 10 mm. Range of 8 mm to 10 mm. So depth of penetration is in the range of 8 mm to 10 mm. Fine, you just release the needle and you'll see up to how much depth needle is going on. That depth will give you the grade of bitumen. Fine. So this is this is how you'll try to find out the grade of the bitumen, and it indirectly measures the softness of the bitumen. For tar, penetration test is not done because tars are very soft to do the penetration test. Fine. So this is the point to be noted here. Depth of penetration is in the range of 8 mm to 10 mm. If grade of bitumen is something like A30, if it is A30, that means bitumen is obtained from Assam. Bitumen is obtained from Assam. And if it is S30, bitumen obtained other than Assam Petroleum. Bitumen obtained from other than Assam Petroleum. Fine. Bitumen obtained from other than Assam Petroleum. That is S30 grade and A30 grade. That is what we'll be saying. So this is penetration value test. Penetration value test is done to find out the softness of the bitumen. Next, ductility. Ductility means ability of the, if I say ductility, ability of the material to be converted into thin wires. Ability of material to be converted into thin wires. Ability of the material to be converted into thin wires. So that means indirectly we are going to measure elasticity of bitumen. elasticity of bitumen. So elasticity of bitumen is what you are going to measure over here. So in this, what you will be doing is, you will take a briquette mold. You will take a briquette mold of, let us say this is 10 mm, this is also 10 mm. 10. Fine, this is 10 mm and this is also 10 mm. You will pour bitumen in it. So if you pour bitumen in it, and after that what you will do is, you will keep on elongate this. This is called briquette mold. Briquette mold. Fine, you will keep on elongating it. Once if you keep on elongating it, it goes something like this. So here you are going to measure the distance of elongation. Fine. Generally, the minimum value should be 75 centimeters. Minimum equals to 75 centimeters. Fine. So minimum ductility should be 75 centimeters for a good bitumen. So you'll keep on elongating it till the time it fails. That is ductility test. So minimum value should be 75 centimeters. This is ductility. Next is viscosity test. Viscosity means resistance to what? Fluidity. Viscosity is resistance to fluidity. So here viscosity is measured in terms of resistance to fluidity. That means here you are going to measure the time taken by the bitumen to flow through the orifice. Time taken by 50 ml of bitumen to flow through the orifice is considered as viscosity. This is 50 ml. Fine. Let us say if it is 50 ml, there will be bitumen in it. You'll heat the bitumen. You'll try to convert the bitumen into liquid. Okay. You'll try to convert the bitumen into liquid, and through the orifice, bitumen has to pass through a beaker. Fine. So the time in seconds. Fine. Time in seconds taken by the fluid to flow through the orifice and fill the beaker for a 50 ml is considered as viscosity. Resistance to fluidity. That means if fluidity is more, that means viscosity would be less. So if time taken is more, then viscosity is high. And if time taken is less, then viscosity is less. Viscosity is less, that means fluidity is more. And here fluidity is less. Sir, which one do you prefer, high viscosity or low viscosity? It's not like that. Depending upon the situation, in some cases you require, in repair works, you require high fluid bitumen. That means viscosity should be less. In some cases you require strong bitumens, hard bitumens. Their viscosity should be high. So depending upon the situation, we will be using the viscosity test. So viscosity is measured in terms of time in seconds required by the bitumen to flow through an orifice into a beaker of 50 ml. That is viscosity test. Resistance to fluidity. Okay. Yeah. Next, softening point test. Softening point test. So here you are going to measure the temperature at which bitumen attains certain amount of consistency. Temperature at which bitumen attains certain amount of consistency. certain amount of consistency. Consistency means indirectly it is like temperature at which bitumen can flow easily. Temperature at which bitumen can flow. That is what we'll be seeing here. So that apparatus that is used for softening point test is ring and ball apparatus. Ring and ball apparatus. So what will be there is generally there will be a ring. On the top of the ring there will be ball, and here let us say there will be a thermometer. Fine, and there will be ball on top of it, and ring is filled with bitumen. Ring is filled with bitumen. Okay, so you'll keep on increasing the temperature of it. You'll keep on increasing the temperature of it. At certain temperature, bitumen tries to flow like liquid. If bitumen tries to flow like liquid, ball comes and falls. Ball comes and falls on the bottom base. Okay, so the temperature at which ball falls is considered as softening point test. Softening points, the name itself says the temperature at which bitumen gets softened. That is the reason I said certain amount of consistency. This apparatus is called as ring and ball apparatus. Ring and ball apparatus. This apparatus is called as ring and ball apparatus. Softening point test. Fine. So thermometer softening point test is what you will be seeing over here. Fine. Softening point test. Next points. Next point that you have to these are the major tests that we'll be seeing, and specific gravity test. Anyway, specific gravity test is calculated by picnometer only, and specific gravity of bitumen is generally in the range of will be generally in the range of 0.97 to 1.02. Specific gravity of tar will be generally in the range of 1.2. So bitumen can float in the water. Next is flash and fire point test. Flash and fire point test. Flash means temperature at which bitumen catches fire. Bitumen vapors catches fire. Temperature at which bitumen vapors catches fire. Okay, so that means if you keep on heating it, vapors will be released into atmosphere, right? At certain temperature, that vapors catches fire. That is called as flash point. It just shows a flash of light. Fire point means temperature at which bitumen is ignited. Temperature at which bitumen is ignited. That means bitumen catches fire. Bitumen itself has to catch fire. Okay, here bituminous vapors just shows some flash of light, flash of fire. Here totally it will be fired. That is fire point test, and that apparatus used for this Penske-Martin closed and open cup apparatus. Closed and open cup apparatus. So these are the different Penske-Martin actually. Penske-Martin and Penske-Martin, different names will be there. So anyway, this is the flash and fire point test. Major test that I have discussed over here. There are different points also. Accordingly, you have to solve it. Fine. So now let's solve some problems. The result of ring and ball softening point test on asphalts is given in terms of, so number of views are getting reduced. Anyway, please give me the answer. Result of ring and ball softening point test on asphalts is given in terms of. is given in terms of? Please give me the answer. So result of ring and ball softening point test. Softening point test, the you'll get in terms of what? In terms of temperature. Softening point test temperature, right? What is viscosity over there? Softening point test is temperature. Next, the following general statements may be made about the penetration value and softening point of the bitumen. Okay, higher the penetration value, higher the softening point. Higher the penetration value, lower the softening point. For very high and very low penetration value, softening point is very low. Absolutely no correlation can be drawn between penetration value and softening point of bitumen. Please give me the answer. Please give me the answer. B. So why B? Higher the penetration value. See, penetration value is more means bitumen is very soft. So if it is very soft, just by giving small amount of temperature, it will fall. Right? See, if bitumen is soft, just see here. If bitumen is soft, softening point test, if bitumen is very soft, if you give small amount of temperature, bitumen can easily flow into it. Right? So softening point would be less. At lower temperature itself, it will fall. So if penetration value is more, bitumen is soft, penetration value is more, bitumen is soft, and softening point is also very low. Lower is the softening point. Your option is B. Fine. Next. Bituminous materials are used in highway construction primarily because of their cementing and waterproofing properties, load bearing capacity, high specific gravity, black color which facilitates road marking. So bitumen materials are used in highway construction primarily because of what? I have just given primarily because of bitumen materials are used in highway construction primarily because of cementing and waterproofing characteristics. I told you bitumen is being used because it can bind. Cementing means binding properties and waterproofing characteristics. Next, penetration test of the bitumen is conducted at a temperature of 25 degrees Celsius. See, for that you have to read in-depth test. If you read in-depth, then only you can solve this. But anyway, recently these type of questions are not asked. Anyway, penetration test is conducted at a temperature of room temperature, 25 degrees Celsius. Okay. Next, the consistency and flow resistance of bitumen can be obtained from which of the following test? Consistency and flow resistance of the bitumen can be obtained by which of the following test? Consistency and flow resistance of the bitumens can be obtained by which of the following test? Consistency and flow resistance of the bitumen can be obtained by which of the following test? So you said viscosity test. Yeah. Why viscosity test? See, consistency is obtained by softening point test, but resistance to flow can be obtained only by viscosity test. Fine. So at the same time, if you are saying resistance to the flow from viscosity, an idea regarding to consistency you can get, whether it is soft, hard, and based on that you can say something. So the best answer for this, the resistance to the flow can be obtained only by viscosity test. So your option is D. Okay. Next, resistance to flow, ability to deform under load, safety. So here let us say you don't know resistance to the flow. Sir, you just said resistance to the flow, viscosity test. There is no option here. Leave that. So resistance to the flow we don't know. But we know the other things. Ability to deform under the load is ductility. Safety, flash and fire point test. Fine. So B2, C3. Then the rest is A1, that is penetration test. So your option would be 2, 1, 3. This is how you will solve this. Actually he should give viscosity test, but he has given resistance to the flow. There is no other option, so you will go for penetration test. Okay, don't get confused with it. Yeah. Fine. Next. fine. See this question. Two bitumen samples X and Y have softening points 45 degrees and 60 degrees Celsius respectively. Consider the following statements. Viscosity of X will be higher than Y at the same temperature. Penetration value of X will be lesser than Y under the standard condition. What is the correct option evaluating the above statements? So just say whether statement 1 is true, statement 2 is true or false. Please. Two bitumen samples are there of X and Y with softening points 45 degrees and 60 degrees Celsius. Based on that, tell me the value of viscosity and penetration value. What you can guess from that? Please let me know. Atul is saying both are false. What about you, Soumya? You are not there. So Soumya said both true and Atul is saying both are false. Softening point 45 degrees Celsius and softening point 60 degrees Celsius. Which one is harder? If softening point is less for X, Y, fine. Let us write X, Y here. So if I take X, softening point X, Y, softening point, so 45 degrees Celsius, 60 degrees Celsius. So it requires more temperature to become soft. It requires less temperature to become soft. So this is soft compared to that of this. So this will be hard. Fine. So if this is soft, viscosity value. Viscosity would be viscosity. That means let us say this is liquid, this is solid. Just think the worst case possibility. This is liquid, this is solid. So time taken for this would be less. Time taken for this to pass through the beaker would be more. So if time taken is less, viscosity is less. If time taken for this to pass through the beaker is more, viscosity will be more. So viscosity of X is less compared to that of viscosity of Y. Next, penetration value. Penetration value. Fine. If it is soft, penetration value will be more because needle can go easily to the downwards. If it is hard, penetration value would be less because if it is hard material, needle can't penetrate. If it is soft, needle can easily penetrate. So viscosity of X is less than viscosity of Y and penetration value of X is more than penetration value of Y. So we'll see the option. Viscosity of X is higher than viscosity of Y. It is wrong. Penetration value of X will be lesser than that of Y under standard conditions. This is also wrong. So both are false. Option is C. I don't know why you got both are true. Both are true. So this is both are false. So go from very basics. See which is soft, which is hard. You will get your answers. Fine. So any doubts up to here? The penetration value of the bitumen sample tested at 25 degrees Celsius is 80. When the sample is heated to 60 degrees Celsius and tested again, the needle of the penetration test apparatus penetrates the bitumen sample by d mm. The value of d cannot be less than. The value of d cannot be less than. The value of d cannot be less than. Please give me the answer. Value of d cannot be less than. The penetration value of a bitumen sample tested at 25 degrees Celsius is 80, and when the sample is heated to 60 degrees Celsius and tested again, the needle of the penetration test apparatus penetrates the bitumen sample by d mm. The value of d cannot be less than, he is asking. What is that value? What is that value? Atul is said 8 mm. What about you, Soumya? What about you? Don't know. Why you don't know, yaar? If penetration value is 8 m at 25 degrees Celsius, penetration value is 80. At 25 degrees Celsius, penetration value is 80. Fine. 25 degrees Celsius, penetration value 80 means penetration value equals to, so you have to use common sense. Penetration value equals to 80 means what is the depth of penetration? Depth of penetration equals to 8 mm. Fine. At 25 degrees Celsius, depth of penetration is 8 mm. Now if you increase the temperature, if you heat it more, what happens? Bitumen even becomes softer. Bitumen even becomes softer. So if it's soft, obviously penetration value will be more than, depth of penetration will be more than 8 mm, right? Depth of penetration will be definitely more than 8 mm. That means it cannot be less than 8 mm. Because it is soft. Initially it is hard, now it is soft. During hard itself, if 8 mm penetration is there, if it becomes soft, the penetration will be even more. So the depth will be more than 8 mm. Depth of penetration will be more than 8 mm. So it cannot be less than 8 mm. That's it. That is the idea. Here you just have to use basic concepts. Okay, now is it clear? Fine. So now comes the next important concept in this, Marshall mix method of design. Marshall mix design. Marshall mix design. So Marshall mix design, the major idea is very simple thing. Marshall mix design, the major idea is to find out how much amount of, in Marshall mix design, the idea is very simple. It is to find out how much amount of bitumen is to be used for optimum strength. In an aggregate, how much amount of bitumen is to be used for an optimum strength. So what he has done is, he has prepared a mold which is called as Marshall's mold. So what, he'll be taking a beaker, he'll be taking the beaker, in that beaker he'll be adding coarse aggregates, he'll be adding fine aggregates, he'll be adding some filler materials, he'll be adding some filler material also. Fine. He'll be adding some filler materials. He'll keep on heating it. Now he'll heat bitumen at somewhere else. He'll heat the bitumen at somewhere else, convert that into liquid, and he'll pour the bitumen in this, and then he'll mix it properly. Fine. He'll mix it properly, and he'll keep that in a mold which is called as Marshall's mold. Whose diameter is 6.35 mm and depth is 10.15 mm. Diameter is 6.35 mm, depth is 10.15 mm. You'll fix that in this mold properly. Once you fix it, and by hitting and fixing it, you'll make it hard. You'll immerse this in the water at a temperature of 60 degrees Celsius. Fine, 60 degrees Celsius, and then you'll try to apply the load. You'll apply the load diametrically. Why, sir? Because in the road thickness will be less. Fine. Generally for road, thickness will be less, length will be more, right? So you'll be applying the load diametrically. Rate of loading will be generally 5 mm per minute, I think. Fine. And then you will measure the flow value, which will be given as 0.25 mm. Like, flow value, if it is 4 to 8, 4 to 8, then deformation would be, deformation is generally given as 4 multiplied with 0.25 to 8 multiplied with 0.25. So that would be 1 to 1 by 4 2. So if flow value is in the range of 4 to 8, that means deformation would be 4 multiplied with 0.25, 8 multiplied with 0.25. So he will be measuring the flow value and you are going to measure the loading, and we'll see with different bitumen quantities. We'll try to repeat this test. We'll try to repeat this test with different bitumen quantities. Fine. From here, now finally, what will be there in the Marshall's mold? If you see what will be there in the Marshall's mold, coarse aggregates, there will be coarse aggregates, there will be fine aggregates, filler material, and bitumen voids will be there. Fine. Coarse aggregates, fine aggregates, filler material, some filler, this would be bitumen, and this is voids. This is voids. Fine. So let us say this is mass of coarse aggregates, and this one is mass of fine aggregates, mass of filler, mass of bitumen, and for voids there will not be much mass. Okay, for voids there will be volume, but mass will not be there. Okay, so this is volume of voids, volume of bitumen, volume of filler material, volume of fine aggregates, and volume of coarse aggregates. Fine. VCA, VFA, VF, VB, VB, and this is mass of bitumen, mass of filler material, mass of fine aggregates, and mass of coarse aggregates. Fine. So these are the points that you have to know. This is what is present in the Marshall's mold. Now, if they ask what is the theoretical specific gravity, theoretical specific gravity, GT, GT, theoretical specific gravity. If they ask what is the theoretical specific gravity, generally what is specific gravity? Unit weight of the given sample, unit weight of the given sample, Here, if I talk about theoretical, you should remove voids of the sample of given volume, of the sample of given volume upon unit weight of standard fluid of equal volume. Upon unit weight of standard fluid. Standard fluid is generally taken as water. Standard fluid of equal volume. Unit weight of standard fluid of equal volume. Fine. So that would be equals to, this is rho upon rho W, rho T upon rho W. Unit weight or density both are same here. Fine. So here what I will take is mass of mold, total mass, upon V minus VB, volume of voids. This is theoretical specific gravity. You have to remove this, and rho W, generally it is taken as 1 gram per cc, right? So you can remove this. Okay. So mass of mold means mass of coarse aggregates plus mass of fine aggregates plus mass of filler material plus mass of bitumen, right? Whole thing upon total volume of coarse aggregates plus volume of fine aggregates, volume of filler material plus volume of bitumen, right? So these are the things. This is theoretical specific gravity. And volume can be written as generally mass upon density. That can also be written as mass upon G multiplied with rho W. Generally rho W is 1, so you can write mass upon G. right? So if I have to write GT would be equals to theoretical specific gravity equals to mass of coarse aggregate plus mass of fine aggregate plus mass of filler material plus bitumen mass of bitumen whole thing upon mass of coarse aggregates upon G of coarse aggregates, specific gravity of coarse aggregates, mass of fine aggregates upon specific gravity of fine aggregates plus mass of filler material upon specific gravity of filler material plus mass of bitumen upon specific gravity of bitumen. This is GT. This is GT. Fine. So if theoretical specific gravity is asked, you are going to find something like this. If mass and specific gravities of different things are given to you, you are going to find out like this. And if they say apparent specific gravity GM is called as apparent specific gravity or bulk specific gravity. Apparent specific gravity or bulk specific gravity. Bulk specific gravity, when it is simply, what you can say is a rho of mole upon rho of water. Generally rho W is taken as 1, so this would be equals to mass of mole upon total volume. Mass of mole upon total volume is apparent specific gravity. Mass of mole upon volume minus volume of voids would be true specific gravity, right? So you should know the difference between these two things. GT equals to mass of mole upon V minus VV. Okay. Actually specific gravity does not have any units, but since if you take rho W equals to 1, it can be given in gram per cc. Don't get confused. Okay. If you are saying gram per cc means indirectly he is saying unit weight. Rho W he is taking it as 1. Okay. So GT is something like this. If they ask percentage of volume of voids, that equals to volume of voids upon volume, total volume multiplied with 100, right? Percentage of volume of voids upon total volume multiplied with 100. So how you can write that? V equals to mass of mole upon specific gravity, V minus VV equals to mass of mole upon GT, right? So this is mass of mole upon GM minus VV equals to mass of mole upon GT. So VV equals to multiplied with 1 upon GM minus 1 by GT. Whole thing upon V. Whole thing upon V is mm upon GM. So this would be equals to GT minus GM upon GT multiplied with 100. So percentage of volume of voids. If they ask what is the percentage of volume of voids, GT minus GM upon GT multiplied with 100. Upon GT multiplied with 100. Fine. Upon GT multiplied with 100. This is how you will try to find out percentage of volume of voids. Directly, if you remember this, your time will be saved. You can directly solve it. Just find out GT, GM, percentage of volume of voids. Next, percentage of volume of voids in mineral aggregates. Percentage of volume of voids in mineral aggregates is percentage of volume of voids plus percentage of volume of bitumen. Fine. You know how percentage of volume of voids in mineral aggregates means. What exactly this means is, initially you will be having coarse aggregates, filler material and fine filler, right? In this there is voids. Now if you add bitumen will go and sit in this voids, right? So in this, if I am trying to find out percentage of volume of voids in mineral aggregates, in this one, that is equals to, in this voids there will be bitumen and voids, right? So it is volume of bitumen plus volume of voids, right? That is how you will try to see this. So percentage of volume of voids, you know how to calculate this. Percentage of volume of voids equals to GT minus GM upon GT multiplied with 100. Percentage of volume of bitumen, that equals to VB upon total V multiplied with 100. VB, but that would be equals to mass of bitumen upon GB of bitumen. Total volume would be equals to mass of mole upon GM, apparent specific gravity. So it can be simply given as MB upon mm multiplied with GM upon GB, whole multiplied with 100. So this is percentage of volume of bitumen. Volume of bitumen. Next, if they ask voids filled with bitumen, VFB, voids filled with bitumen, that equals to percentage of VB upon percentage of VV plus percentage of VB. This is voids filled with bitumen. Fine. So these are certain points that you have to remember. Fine. Now once you have done this test, the results of the test, how you are going to see that? So Marshall stability value with respect to percentage of bitumen. Fine. So this is Marshall stability value. Marshall stability value is like load at which mold fails. Marshall stability value, load at which mold fails. Okay, load at which mold fails. Marshall stability value, that means if you are applying the load diametrically, the load at which mold fails is considered as Marshall stability value. If you keep on increasing the bitumen, initially if bitumen is not there, the value would be less. If you keep on increasing the bitumen at some optimum content, you will get the maximum value of Marshall stability. I mean maximum value of this one. Fine. So at this point, this is called as optimum binder content. This is called as optimum binder content. Fine. So initially cementing properties is less, so if you keep on adding the bitumen, the value keeps on increasing, it reaches to the maximum. And further, if you add bitumen, what happens is it tries to flow like liquid, its fluidity will increase. Fine. So the value will keep on decreasing. So optimum binder content is the content of bitumen at which Marshall stability value is maximum. Generally this would be at 340 kgs. Generally it is at 340 kgs. Next, flow value. So with increase in the percentage of bitumen, what happens to the flow value? With increase in the percentage of bitumen, what happens to the flow value? Flow value will also keep on increasing, something like this, because obviously it tries to flow, right? So flow value will also keep on increasing. Flow value is given in how much terms of mm? 0.25 mm. In terms of 0.25 mm. In terms of 0.25 mm. Like if flow value is 4, then flow value is 4, deformation is 1, flow value is 8, deformation will be 2. That is the idea. Fine. This is flow value. Next GM, specific gravity, apparent specific gravity. Apparent specific gravity also happens to be same thing as that of Marshall stability value. It also increase up to certain point, and after that it will decrease. Fine. Next, percentage of voids filled with bitumen. Percentage of voids filled with bitumen. With increasing in the bitumen content, it keeps on increasing. Fine. Generally the optimum content will be at the point where this is 75%. Next, percentage of volume of voids. So with increase in the percentage of bitumen, percentage of volume of voids, what happens? It keeps on decreasing. The optimum content would be generally at 3 to 5%. So these are the graphs. For different analysis. Fine. Volume of voids will decrease if you keep on adding the bitumen. Volume of voids, because all the voids will be filled by bitumen. That is one thing. Next, voids filled with bitumen, it will keep on increasing with increase in the percentage of bitumen. Flow value will keep on increasing. Marshall stability value, it increases up to certain point, and after that it will decrease. Fine. So based on this, you will try to find out the optimum content of the bitumen. So any doubts in Marshall stability value, you can ask me. Good evening, Bhaskar sir. Any doubts, guys? No one is commenting. If you're having any doubts, please let me know. Any doubts? Any doubts? Soumya, Atul, any doubts? If you're having any doubts, let me know. If not, we'll solve the problems. Clear? Yeah, fine. So we'll try to solve some problems based on this. We'll go from last only. What a big issue. So in Marshall method of mixed design, the problem that is given to you is in Marshall method of mixed design. In Marshall method of mixed design, the coarse aggregates, fine aggregates, filler and bitumen having respective specific gravities of 2.62, 2.72, 2.7 and 1.02 are mixed in the ratio of 55%, 34.6, 4.8 and 5.6% respectively. The theoretical specific gravity of the mix would be. Try to find out this. What is the theoretical specific gravity of the mix? Try to find out the theoretical specific gravity of the mix. .44. Atul has given the answer. What about you, Soumya? .44. So the question has to be solved in a simplest way possible. What he is saying in Marshall method of mixed design, the coarse aggregates, fine aggregates, bitumen having respective specific gravities, fine, having the respective specific gravities of coarse aggregate equals to 2.62, specific gravity of fine aggregates equals to 2.72 and specific gravity of filler material equals to 2.70, and specific gravity of filler material is 2.70, and specific gravity of bitumen is 1.02, and mass, he's saying 55%. If you take that as 55 grams, mass of filler material fine aggregates is 34.6, and mass of filler material would be equals to 4.8, mass of bitumen would be equals to 5.6, right? If you add, you'll get 100. Directly, that is the meaning of it. Theoretical specific gravity, that would be equals to 55 plus 34.6 plus 4.8 plus, if you want me to write a formula, it is simple: mass of coarse aggregates plus mass of fine aggregates plus mass of filler material plus mass of bitumen, whole thing upon mass of coarse aggregates upon specific gravity of coarse aggregates, mass of fine aggregates upon specific gravity of fine aggregates, mass of filler material upon specific gravity of filler material, and mass of bitumen upon specific gravity of bitumen. So this is equals to 55 plus 34.6 plus 4.8 plus 5.6, whole thing upon 55 upon 2.62 plus 34.6 upon 2.72 plus 4.8 upon 2.7 plus 5.6 upon 1.02. So whatever the value you are getting, people are saying that as 2.44. This is how you'll try to find out. Okay? No doubts? Fine, we'll move to the next question. In Marshall method of mixed design, the coarse aggregates, fine aggregate, fines and bitumen having respective value of G as something like this, and in mixed relative proportions are given to you. The theoretical specific gravity of mix and effective specific gravity of the aggregate in the mix respectively are. He is asking theoretical specific gravity of mix GT and effective specific gravity of the aggregates, not bulk specific gravity, effective specific gravity of the aggregates in the mix are. So please give me the answer. Please give me the answer for this. What is your answer for this? Please give me the answer. Atul is saying A. What about the other person? Soumya is also saying A. Fine. Don't you think it is same as that of the previous one? In calculating GT, this is 2.6, 2.7, 2.6, 2.7, 2.65 and 1.01. 2.65 and 1.01, and MCA 55, 35.8, 35.8, 35.8, 3.7 and 5.5, right? Yeah. So if you substitute everything over here, just substitute the thing and you'll get somewhere here to 2.42 only. So let us say you got approximately, they are saying 2.44, right? So it will not change. Now he is asking specific gravity of what? Effective specific gravity of aggregates. So effective specific gravity of aggregates means what are the things that you will consider? What are the things that you will consider? All these things you will be considered. You won't consider this. Fine. And effective specific gravity of aggregates only he is asking, right? Fines is also considered as aggregates only. So then if specific gravity of aggregates, if you have to write, then it is simply mass of coarse aggregates plus mass of fine aggregates plus mass of fines upon mass of coarse aggregate upon specific gravity of coarse aggregate, mass of fine aggregate upon specific gravity of fine aggregate, and mass of fines upon specific gravity of fines, right? So this is the idea. So what is the answer you're getting here? Just substitute everything and tell me what is the answer. You're getting somewhere around 2.63, right? Is it correct? Then only the option would be A. If not, if there is any correction, please let me know. He has asked aggregates. He is not asking what is GM. Fine. Next question. We'll go for the next question. All the questions are of Marshall's mix method only. So in Marshall testing of bituminous mixes, as bitumen content increases, the flow value, what happens to the flow value in Marshall method of bitumen mixes? In Marshall method of bitumen mixes, as the bitumen content increases, then flow value what happens? Make it fast. What happens to the flow value? What happens to the flow value? If bitumen content increases, then flow value will increase monotonically. It increases monotonically. Simple. Flow value will increase. In Marshall sample, next question is, in Marshall sample, bulk specific gravity of the mix and aggregates are 2.34 and 2.546 respectively, and the sample indicates 5% of bitumen by weight of the specific gravity 1.10. The theoretical specific gravity of mix is 2.441. The voids filled with the bitumen in the Marshall sample is. What is the voids filled with the bitumen in the Marshall sample? So please try to find out. He has given GM, G of aggregates and percentage of bitumen, and then specific gravity of bitumen, theoretical specific gravity of the mix. So he is asking what is the voids filled with bitumen in percentage. Voids filled with bitumen in percentage. 70.81 percentage. And Atul, you're not there. So what is given to you? He's asking what is the percentage of voids filled with bitumen, right? Percentage of voids filled with bitumen. Voids filled with bitumen, that equals to percentage of VB upon percentage of VB plus percentage VV. So percentage VV, if I have to write, that equals to GT minus GM upon GT multiplied with 100. Fine. So GT is 2.441 and GM is 2.324. This is 2.441 and minus 2.324 upon 2.441 multiplied with 100. So what is the value of percentage of volume of voids? Please give me, this is percentage of volume of voids. This is how you will calculate this. Percentage of volume of bitumen, that would be equals to GB upon MB upon total mass of mole multiplied with GM upon GB multiplied with 100. This value is given as 5%. 5 multiplied with 2.324 upon 1.01. What is this value? And totally tell me this value. 4.79 percentage. This is 4.79 percentage. And what is percentage of volume of bitumen? 4.79% percentage of volume of bitumen. What is this value? And finally tell me what is this value. 11.62. This is 11.62. So this is 11.62 upon 11.62 plus 4.79. Your answer, what she said, is 70.81 percentage. That is one of the thing. Voids filled with bitumen, 70.81 percentage. This is done. Same question, not a bigger thing issue. Is there any other problems you want me to solve? Any other things that you want me to solve? So with this, your highway materials is completed. And is there anything that you, I think one question I wanted to discuss, yesterday I forgot to discuss that question. That is something related to road user characteristics. Yeah. So road user characteristics, your site. This question I have not discussed. I'll discuss this question also. That is related to your site vision. Fine. So the question that is given to you is, a sign is required to be put up asking drivers to slow down to 30 kilometers per hour before entering zone Y. Okay, this is zone Y. Before entering zone Y, your speed should be 30 kilometers per hour. Fine. On this road, vehicle require 174 meters to slow down to 30 kilometers per hour. That includes perception reaction time also. The sign can be read by 6x6 visual drivers from a distance of 48 meters. Now the sign is placed at a distance of x from the start of zone Y, so that even a 6x9 vision driver can slow down to 30 kilometers per hour before entering the zone. This, the minimum value of x is, he is asking. Fine. what is the minimum value of x. Fine. There is zone y. Before entering zone y, your speed should be, let us say this is start of zone y. Okay. And your signpost is kept at a distance of, of x from here. This is the signpost. This is kept at a distance x, so that a person coming over here can see this post and he can reduce his speed, and before entering zone y, his speed would be something around 30 kilometers per hour. So this distance is 174 meters. 174 meters. Fine. 174 meters. Okay. On this road, vehicle requires 174 meters to slow down to 30 kilometers per hour. Okay. So that means, and a 6x6 vision driver from a distance of 48 meters, he can see the signpost clearly. That means he sees the signpost, that 30 kilometers per hour signpost will be there. He sees the signpost, he'll apply the brake, and then before entering zone Y, he'll be something like this. Now, what is 6x6 vision, 5x6 vision, 4x6 vision? 6x6 vision. 6x6 vision means a person can see an object of 8.5 mm diameter from a distance of 6 meters clearly. From a distance of 6 meters clearly. From a distance of 6 meters. From a distance of 6 meters, you can see an object of size 8.5 mm clearly. That means from your second floor, you can see a small stone clearly. Then it is called as perfect vision. That means you don't require any spectacles. This is called as perfect vision. Fine. So this is called as perfect vision. Now, if I say 4x6 vision or 5x6 vision, if your vision is 5x6, that means you can see the object of 8.5 mm dia from a distance of 5 meters clearly. From a distance of 5 meters clearly. So from a distance of 5 meters, you can see an object of 8.5 mm clearly. That is the 5x6 vision. If I say 4x6 means from a distance of 4 meters, that means you require glasses here. You require glasses here. Fine, that is the idea. A idea of perfect vision is 6x6. If it is 5x6, 4x6 means your vision is decreasing. Okay. Now what he is saying, a man with 6x6 vision, can see at a distance of 48 meters clearly. That means from here, if it is at a distance of 48 meters, he will see the sign, he will apply the brake. Once he applies the brake, this is 48 meters, so he will apply the brake here. So 174 meters from here, he will apply the brake just before entering Y. Here his speed would be 30 kilometers per hour. So what would be this distance then? 174 minus 50 is 124. 126 meters. X would be 126 meters. Fine. Well and good. Now what he is saying for 6x6 vision, this is the thing. Now what he is saying is, he is asking what is the value of X to be kept for a 6x9 vision. 6x9 vision person. The person vision is person vision right now is 6x9. Person vision is 6x9. 6x9 means how much, sir? That equals to 2/3. That equals to 4/6. 4/6 is his vision, right? 4/6 is his vision. That means he has to travel even more distance to see the sign. If 6x6 person can see from a distance of 48 meters, from 48 meters he can see, but 4x6 person, he has to go somewhat near to see that. right? So what would be that value? What would be that value? If 6 by 6 person can see from a distance of 48 meters, 4 by 6 person can, from what distance 4 by 6 person can see, that would be equals to 4 upon 6 multiplied with 48 upon 6 upon 6, that is 2 by 3 multiplied with 48, that equals to 32 meters, right? So this is 32 meters now. If this is 32 meters, what would be this value? This is 142 meters. So here you should know the concept, like if 6 by 6 vision means he can see particular thing from a distance of 6 meters clearly. His vision is perfect. 4 by 6 means his vision is not perfect. 5 by 6 means it is lesser than 6 by 6. 4 by 6 means it is lesser than 5 by 6. He has to go even less. That means from 4 meters he can see clearly, but from 6 meters he can't. The same thing, the person has to travel a distance. Or what you can do is, you can keep the signpost even front. If you keep the signpost at a distance of 32 meters from here, then this will be 142 meters. So if he applies the brake, he'll come over here and he'll settle. Just before entering Y, his speed would be 30 kilometers per hour. So I just wanted to discuss this problem with you. Simple problem only, but you should know that concept of 6 by 6 and 6 by 9. Okay. So any doubts in this, you can ask me. Any doubts? Any doubts? Clear? Yeah. So with this, your highway engineering is completed. Maximum part I try to complete it. Fine. Let's take a break for 15 minutes. It's sweating a lot over here. And after the break, we'll try to complete. Complete in the sense, I'll discuss only problems in railways and airport. Important one. Okay. So with that, we'll close off transportation today. In the meanwhile, you just discuss and let me know which subject you want me to start tomorrow. I'll take that subject. Okay. Fine. Let's take a break for 15 minutes, 15 to 20 minutes. Okay. So, hi friends. So, if anyone is there, please comment. Please do comment if anyone is there. If anyone is there, please do comment. 4 people are watching. One is me, and I don't know other 3 guys. Yeah, I took some half an hour break. It was very hot over here. Sorry for that. But I think there is nothing wrong in taking breaks. That's what I feel. I don't know about you guys. Okay. You were there. Soumya is there. I don't know about the other guys. If anyone else is there, please let me know. Fine. Now comes railway engineering. In railway engineering, the major problem was on super elevation or cant. Cant means indirectly super elevation. Atul is also there. Fine. So raising of outer edge with respect to the inner edge is considered as raising of outer edge with respect to the inner edge is considered as cant, right? Or super elevation. Fine. So here generally rails will be of 2 types. Not 2 types. The differences between there are rails. Rails will be a flat-footed type. Okay, this will be generally a flat-footed type. Generally rails will be a flat-footed type, and inner to inner distance is considered as gauge distance. Gauge distance for broad gauge, it is generally taken as 1.676 meters, right? This is for broad gauge. If nothing is mentioned, you will be taking something like this, broad gauge. Okay, so these are rails which is generally a flat-footed type. Fine. The idea is to find out the maximum allowable speed, length of the transition curve, and super elevation or cant. I will be discussing the super elevation or cant over here. Raising of outer edge with respect to inner edge. So raising of outer rail with respect to inner rail is considered as super elevation or cant. Okay, is considered as super elevation or cant, right? So if I take a rail over here, so raising of outer edge with respect to inner edge. Actually, this would be your cant. Raising of outer rail with respect to inner rail is considered as E, super elevation or cant. Fine. Generally here tan theta, if I take this as theta, tan theta equals to E upon G. That equals to V square upon GR, or E would be equals to GV square upon GR, or you can also write E equals to GV square upon 127R. E equals to GV square upon 127R, where G is the gauge distance for different gauges, broad gauge, meter gauges. It will keep on varying. So E is called super elevation, that is GV square upon 127R. That is the cant. Same thing as that of highways, but only difference is here it is GV square upon 127R. Here you are not worried about friction. Friction is very, very less here. Fine. So here there are different types of cants. Since different rails will be moving with different speeds, so we'll be providing a cant. Actual cant that will be provided will be based on equilibrium speed. So that would be V equilibrium square upon 127R. And theoretical cant, superelevation, which is also called as cant, is generally given as is designed for maximum speed, G V max square upon 127R. The difference between theoretical cant and actual cant is called as cant deficiency. The difference between theoretical cant and actual cant. Okay, so theoretical cant is designed for maximum speed. And actual cant is designed for equilibrium speed. Equilibrium speed will be less than that of maximum speed always. Okay, sometimes like 3/5 of maximum speed. So accordingly you have to solve your questions. Fine. Based on this concept, how you are going to solve this? A broad gauge railway line passes through a horizontal curved section of radius 875 meters and length 200 meters. Length of the curve is given. The allowable speed on this portion is 100 kilometers per hour. For calculating the cant, consider the gauge as center to center distance between the rail heads equal to 1750 mm. The maximum permissible cant with respect to the center to center distance between the rail heads. What is the maximum permissible cant with respect to the center to center distance between the rail heads? Based on that, try to calculate it. Try to calculate what is the maximum permissible cant you have to provide. From whatever I have said in the cant, try to find out. One 57.48. Fine. So this is how you'll try to find out. First, what he said, allowable, maximum allowable speed. Radius is given as 875 meters. If radius is not given to you, right, if radius is not given to you and degree of the curve is given to you, let us say if degree of the curve would be equals to generally 1720 upon r. If chain length equals to 30 meters, it is 1720 upon r. Fine. If degree of the curve is given, then radius can be calculated something like this. Once if you know r, the allowable speed, that means V max, you can't go beyond this. V max equals to 100 kilometers per hour. If V max equals to 100 kilometers per hour and G is given as 1.75 meters, 1.75 meters, then E theoretical would be equals to GV square upon 127 R. So what is this value? 1.75 multiplied with 100 square upon 127 multiplied with 875. So what is this value? Please give me the answer. This is E theoretical. He is asking what is E actual that should be provided. E actual, for that you should know Kant deficiency. So you have to remember this table. You have to remember this table in order to find out the Kant deficiency. Let us say type of track, broad gauge, meter gauge, narrow gauge, speed less than 100 kilometers per hour, less than or equal to 100 kilometers per hour, speed more than 100 kilometers per hour, Kant deficiency, allowable Kant deficiency, allowable Kant deficiency, allowable Kant deficiency D is generally given as 7.6 centimeters, 5.1 centimeters, 3.8 centimeters, and if it is speed more than 100 kilometers per hour, then it is 10 centimeters. Fine. So in the question he has not given what is allowable Kant deficiency, then D would be, you will take it as maximum 7.6 centimeters, then E actual would be equals to E theoretical minus D. So what is the value of E theoretical you are getting? E theoretical, what is the value you are getting? E theoretical, what is the value of E theoretical you got, and tell me what is the value of E actual. This is E theoretical. Fine. At the same time, here you have to remember this table, 7.6 centimeters. Now in some cases you have to remember actual Kant values also, not here in some cases. Okay, this would be 16.5 centimeters, and this is 18.5 centimeters, and this one is 10.10 centimeters, and this is 7.6 centimeters. This is allowable actual Kant, allowable actual Kant. Fine. So what is this value? E theoretical, how much you got? Please let me know what is the value of E theoretical. 1.75 100 square upon 127 875. What is this value? What is this value? What is this value, guys? E theoretical. Please let me know. Make it fast. So from that you'll get E actual. So E actual is the one actual Kant that is provided. This is E actual, actual Kant that you will provide, and then there will be Kant deficiency, and there will be Kant deficiency of D. There will be Kant deficiency of D. So total thing would be E theoretical. E theoretical. Okay. 157.48 is E theoretical. Is that what you are trying to say? Fine. If 157.48, what is that 157.48? Please give the things properly. Why? Because I don't know whether it is in meters. I am taking G in meters. 1.75 meters I have taken. So then I think it should be 1.57 meters. Right? 1.57 meters. Is that what you are trying to say? Or what is this value? Please give me this value properly. (157.48 mm). Okay, he is saying 157.48 mm. So 157.48 mm minus 76 mm. So what is this value then? Actual Kant that is provided. What is this value then? 157.48 minus 76 mm. What would be this value? 15 minus 7, 8. This is the actual cant that you are going to provide. See, in the question what he has asked is, in the question, what is the maximum permissible cant? That means the actual cant. Theoretical means that is theoretical value, not the actual value that you are providing. The actual value you will be providing is this one, and there will be a cant deficiency. For vehicles moving at higher speed, there will be a cant deficiency of this much. So theoretical cant is provided. You can allow cant deficiency of up to 76 mm. Then also there will not be much issue. That is the meaning of it. You can allow up to this deficiency, so even then vehicle can move properly without much problem. That is the meaning. Allowable cant deficiency. You can allow up to this much. Fine. So E actual that is provided is somewhere around 81 mm. Fine. Now is it clear? So always remember, this is the maximum permissible cant, means this is the cant that you can provide. Actual cant that is provided is this much. This much amount of cant deficiency is allowable. If it is not given in the problem, you have to remember that table. If you don't remember, you will not be able to solve this question. Am I clear? Am I clear? Any doubts in this? You can ask me. Actually, I have discussed railway and airport. That videos is also there. You can go through that videos if you are having any doubts. Any doubts in this? You will be providing actual cant, not maximum. This is the cant that can be cant deficiency that is allowed. Allowable cant deficiency. This is actual cant. You will always provide actual cant. So first idea is to find out theoretical cant with maximum speed, and cant deficiency you have to assume, and actual cant that is provided is this much. Fine. So this is one of the thing that you have to remember. Problems can be asked, and problems can be asked in negative super elevation also. That means there will be a main track and there will be a branch track. Fine. So let us say this is main track. This is main track. Main track, and let us say this is branch track. Branch track. Fine. For main track, this is inner rail. This is outer rail. Right. Whereas for branch track, this is inner rail. This will be outer rail. So if you raise the outer rail with respect to inner rail, then what happens? It's like for branch track, inner rail will be at bottom compared to that of outer rail. So that is, if it is positive super elevation for main track, it would be negative super elevation for branch track. How exactly you have to visualize this? Yes. Fine. So the actual cant would be this. For main track, this is outer rail and this is inner rail. So with not much, this is outer rail, this is inner rail for main track. Okay. Raising of outer rail with respect to inner rail, and this would be actual cant, E actual. Fine. And if this is E actual, there will be some cant deficiency, and you'll be providing E theoretical. Let us say this is cant deficiency D, and this whole thing is E theoretical. So when a problem is given to you, first E theoretical you will calculate, that is G V max square upon 127 R. G V max square upon 127 R. So, and E actual would be equals to E theoretical minus D. E theoretical minus D. This is how you'll find out E actual for main track. For main track. For main track. Okay. So if this is how you'll calculate for main track, then for branch track, what you will be doing? What you will be doing for branch track would be, in branch track, if you see, this is inner rail. For branch track, this would be inner rail. This is outer rail. So outer rail will be at lesser super elevation compared to that of inner rail. This is for branch track. For branch track. This is for branch track. Now if you see, for branch track, this will be the negative super elevation. This is your E actual only, but this will be negative. So here if you want to find out E theoretical for branch track, generally it is E actual plus D. Here that E actual is minus. You'll calculate E actual for main track, that is E theoretical minus D, and for E theoretical for branch track, E theoretical for branch track would be equals to D minus EA. Once if you know E theoretical, that equals to G V max square upon 127R. So from here you can calculate what is the maximum allowable speed on branch track, that equals to 127R multiplied with E theoretical of branch track upon G. Right? So E theoretical is calculated as D minus EA. This is negative super elevation, main track and branch track. So if it is positive super elevation for main track, then it is the negative super elevation for branch track. This is what this you have to be clear with this. Fine. Any doubts in this? You can ask me. Any doubts in this? Please go ahead and ask me. Any doubts? Any doubts, please? I don't understand if it is clear for previous thing or this one. Please comment if you are having any doubts. Clear? Yeah, fine. Next, maximum allowable speed. So maximum allowable speed equals to minimum of 4 criterias you have to generally see. Maximum specified speed as per railways, maximum specified speed as per railways, and maximum speed based on Martin's formula, So based on Martin's formula, V max would be equals to 4.35 under root of R minus 67 kilometer per hour, where R equals to radius of curve in meters. radius of curve in meters. Fine, this is Vmax. If speed is less than, if sanction speed is less than 120 kilometers per hour, this is sanction speed is less than 120 kilometers per hour, this is equals to 4.58 times root r if maximum speed or sanction speed is more than 120 kilometers per hour. This is as per Martin's formula. Next, maximum speed based on super elevation criteria. Maximum speed based on super elevation. Maximum speed based on super elevation. So just now we have seen Vmax. Vmax would be equals to under root of 127 R E theoretical upon G. E theoretical would be equals to E actual plus D. Fine. Next, maximum speed based on length of transition curve. Based on length of transition curve. Length of transition curve. Maximum speed based on length of transition curve. So that is equals to Vmax equals to minimum of 134 L upon E or 134 L upon D, where L equals to length of transition curve in meters, length of transition curve in meters, and E equals to actual cant in mm, and D equals to cant deficiency in mm. Cant deficiency in mm. This is if sanction speed is less than 120 kilometers per hour. If sanction speed is more than 120 kilometers per hour, then Vmax equals to minimum of 194 L upon E or 194 L upon D. Fine. So these things you have to be very much clear. You will get finally everything in kilometers per hour. So minimum of all these four criteria. If a problem is given to you, you have to check all the criteria. Minimum of all these criteria will be your maximum speed, and very rarely you will see a problem on this. Generally problem will be asked from super elevation only. That's why I have discussed super elevation criteria. Fine. Any doubts in this? You can ask me. If you don't have any doubts, then I'll go for airport. Problems on airport. I'll not say everything in the airport. Problems on airport. Any doubts in this, guys? Any doubts in this? Please let me know. Any doubts? No. Fine. Next, length of runway. In the airports, the major point would be length of runway. Length of runway. And in length of runway, corrections for the length of runway. What is runway? Before flying, aircraft travels up to some distance and then it will fly. Right? So this length is called as length of runway. Length of runway. Length of runway. Fine. So here in the length of runway, there are different types of corrections. First correction being correction due to elevation. Correction due to elevation. So correction due to elevation, if you see with increase in the elevation, what happens? Air density decreases. If air density decreases, then you require more amount of length, you require more amount of pushing for rising, right? So correction due to elevation would be 7% for every 300 meters above MSL. So for every 300 meters above MSL, the runway length should be increased by 7%. This is correction due to elevation. Next, correction due to temperature. Correction due to temperature would be equals to 1% for every 1 degree increase in temperature, increase in temperature, increase in temperature above standard temperature, above standard temperature, above standard temperature. Okay, what happens? Same, if temperature is increased, automatically air density will be decreased, so you will be requiring more amount of runway length for rising. Okay, so what is standard temperature? Standard temperature would generally taken as 15 degrees Celsius minus 0.0065 multiplied with elevation, multiplied with elevation of airport, elevation of airport. This is standard temperature, ART, which is also called as airport reference temperature, airport reference temperature, airport reference temperature, which is generally given as TA plus Tm minus TA upon 3. If it is TA and Tm is given, go with it. If directly ART is given, go with that. What is TA? Average of average daily temperature, or monthly mean of, I'll say monthly mean of average daily temperature, average daily temperature of hottest month, of hottest month. Next, Tm, Tm equals to monthly mean of maximum daily temperature, maximum daily temperature of hottest month, maximum daily temperature of hottest month. Fine. So this is ART, Tm plus Tm minus TA upon 3. So monthly mean of average daily temperature and monthly mean of maximum daily temperature. So that means, what exactly this means is, in a month there will be, like, in a month, average daily temperature. That means if today, let us say 1, 2, 3, so on up to 30 days. So average daily temperature of today would be some 25 degrees. This is average. Monthly maximum would be somewhere around 35 degrees Celsius. Similarly, average is 28. Maximum would be 38. Average would be some 21. This is 32. It keeps on going, right? It keeps on going somewhere around. Average means from morning to night, you'll take whole average. Maximum means maximum will generally occur at the afternoon. Let us say some 40 degrees, and let us say this is some 29 degrees. Average of all these things is TA. That means 25 plus 28 plus 21 plus so on up to 29 upon 30 is TA. 35 plus 38 plus 32 plus so on up to 40 by 30 is Tm. Fine. This average equals to this one, this average equals to this. Once you know that, you can find out airport reference temperature. Once you calculate airport reference temperature, delta T would be equals to airport reference temperature minus standard temperature. Fine. So for every 1 degree increase in, delta T, not 1 degree increase, that means, see, whatever the difference you are getting, you will be increasing the length by that %. For every 1 degree Celsius increase in temperature. Fine. So ART minus ST. If you are getting 20 degrees Celsius for this, then you will be increasing by 20%. Fine. Next, combined correction. Combined correction due to elevation. Combined correction due to elevation and temperature. Combined correction due to elevation and temperature should not be more than 35%. Combined correction due to elevation and temperature should not be more than 35%. Okay. Combined correction due to elevation and temperature. If it is more than 35%, you have to redesign it. Next, finally, if this is solved, then correction for gradient. Correction for gradient. Correction for gradient. That means if you keep on increasing the gradient, you require more length because there will be more amount of resistance. Right? Correction for the gradient would be one 20% for 1% rise in the gradient, 20% for every 1% rise in gradient, 20% for every 1% rise in gradient. Okay, so these are the different types of corrections given by International Civil Aviation Authority. Fine. So read the question properly, and for correction due to elevation is 7% for every 300 meters. Temperature is 1% for every 1 degree increase in the temperature above standard temperature. That means if you are getting 20, delta T is 20, that means you will be increasing by 20%. Combined correction should not be more than 35%, and correction for the gradient is 20% for every 1% rise in the gradient. So if gradient is 0.2%, then you will be increasing this by 4%. That's it. Fine. So try to solve this problem. A runway is being constructed. A runway is being constructed. A runway is being constructed in new airport as per ICAO conditions. The elevation and the airport reference temperature of this are 535 meters above the mean sea level and 22.65 degrees Celsius. Considering the effective gradient of runway as 1%, the length of runway required for the design aircraft under standard conditions is 2000 meters. Within the framework of applying sequential correction as per ICAO recommendations, length of runway corrected for temperature is. Fine. So he has given elevation as 535 meters. Airport reference temperature is 22.65 degrees Celsius. Effective gradient of 1%. And he is asking length of runway corrected for temperature is. What is the length of runway corrected for temperature? Please solve it. Length of runway corrected for temperature, please solve it. So Atul R has given that as 2500 meters. So how exactly you are going to solve this? Fine. What is the elevation that is given to you? Elevation of airport is 535 meters. So an actual length of runway under ideal conditions, that means at mean sea level, is 2000 meters. 2000 meters. So for every 300 meters you will be increasing this by 7%. Now what is the elevation? 535 meters. How much you have to increase? You have to increase this by 535 multiplied with 7 upon 300. This, by this much percentage you have to increase the length. So correction for elevation, this is correction for elevation, correction for elevation, and corrected length would be equals to, what is this value? 535 into 7 upon 300. What is this value? 249.67 meters. He has given something. Anyway, so the percentage, what is this value? 12.53. So this is equals to 12.53 percentage. So if it is 12.53 percentage, then corrected length would be 1 plus 12.53 upon 100 multiplied with 2000. So this is corrected length after runway. Corrected length after elevation, correction due to elevation. Fine. What is this value? Please give me this value. Next, correction due to temperature. For that, standard temperature would be 15 degrees Celsius minus 0.0065 multiplied with elevation. Elevation is 535. Try to find out what is standard temperature. Airport reference temperature is directly given to you. What is the value that is given? 22.65. So delta T would be equals to ART minus ST. What is this value? ART minus ST delta T. What is the value of ART minus ST delta T? So what is this value? 1.1253 into 2000. 2249.67. So this is 2249.67 meters. Okay. Now, what is the standard temperature that you are getting, and what is delta T? Standard temperature is 11.5225, 11.5225, and what is difference between these two things? Delta T. Delta T is how much? 11.3275. Okay, fine. This is 11.3275. And what is delta T? $11.1275. So 11.1275. So increase in length. Increase in length would be, you have to increase this much percentage, 11.1275 percentage. Therefore corrected length after correction due to temperature would be 1 plus 11.1275 upon 100 whole multiplied with, what is this value? You got this as 2249.67. 2249.67. So what is this whole value? So what is this whole value? Corrected length after correction due to temperature. What is this whole value? What is this value you are getting? 1.12, 2500 meters. Fine. So this is what he has asked. You'll stop the question here. Okay. Your answer is C, 2500 meters. Fine. Now, if he asked after the gradient correction also, then how will you solve this? So first you have to see correction due to percentage of correction, combined correction. Combined correction, first check what is the combined correction. Percentage of combined correction, that is equals to 2500 minus 2000 upon 2000 multiplied with 100. So that equals to 500 upon 2000 multiplied with 100. This would be 25%, not greater than 35%. Hence it is okay, not a bigger issue. Fine, it is okay. Now correction for gradient. Correction for gradient. So if I say what is the gradient that is given to you, 1%. So correction for gradient would be 20% for every 1%. For every 1%. So gradient given over here is 1%. So correction would be 20%. Now corrected length. Corrected length would be corrected length equals to 1 plus 20 by 100 multiplied with 2500. 1.2 times 25. So this would be 3000 meters. If they ask final correction, correction after correction, if you have to do correction for gradient also, you can stop here, but in the examination if they ask correction for the gradient also, then you will do something like this. Fine. So if a problem comes, try to solve in this fashion. Done. Next, suddenly they asked a question of this model, and everyone thought that something that that was not discussed in the class. This is a basic question. The question is, an aircraft approaches the threshold of runway strip at a speed of 1200 kilometers per hour. The pilot decelerates the aircraft at a rate of 1.697 meters per second square and takes 18 seconds to exit runway strip. If the deceleration after runway strip after exiting the runway is 1 meters per second square, the distance of the gate position from the location of the exit of runway. Let us say you don't know anything. You don't know anything. Logically talking, there is a runway. There is a runway. Fine. There is a runway. And after exiting the runway, there will be a gate here. There will be a gate, okay? There will be a gate. Just assume there is a gate. Fine. Now, he started at 200 kilometers per hour and he is decelerating. Decelerating at the rate of 1.675 meters per second square, and he took 8 seconds. Fine. And speed is equals to, initial speed over here is 200 kilometers per hour. 200 kilometers per hour. If you convert that into meters per second, 5 upon 18. Just whatever that is the value. Fine. So this is the runway. This is the runway. After he exits the runway, let us say he is exiting runway at speed v, and let us say this is the gate. Gate means after exiting runway, his deceleration is -1 meters per second square. He has to reduce, and he has to come to stop here. He has to come to stop. Fine. Speed over here is 0, let us say v2, and I'll take this as some v1. Fine. Now how will you solve this? You'll go from your basics. Okay. v1 equals to u plus at. V equals to u plus at. We know that. What is this a value? 200 multiplied with u value 200 multiplied with 5 by 18. Tell me what is this value. So v1 would be equals to 200 multiplied with 5 upon 18, and a value is decelerating. So this is minus 1.675 into 8. From this you'll get what is the speed, v1. Okay, you'll get speed v1. Now once you get speed v1, now Initial speed you know, final speed you know, you have to calculate the distance, and you know what is the acceleration. So what is that you will be using? V2 square minus V1 square equals to 2AS. This is your simple basic physics. V2 is 0 minus V1 you have to calculate 2 multiplied with minus 1 multiplied with S. What is the value of S? If you keep at this distance gate, there will not be much problem. What is 312.15 R? I don't understand. Tell me that in meters per second. What is 312.15? You are saying distance. Tell me what is the value of V1. Tell me what is the value of V1. Final answer. Okay. Tell me what is the value of V1. .004 meters per second. This is 25 meters per second. Fine. So if this is 25, substitute 25 here. 25 by 2, 12.5. Why it is 312.5? Please check it once again. 200 upon 20, let us say, approximately it is 10, 50. 50 minus 16. Okay, fine. Fine, this is the answer that you will get, 312.15 meters. So you should not be like, there is some big concept in this. There is no much bigger concept. It's just your common sense. So for some questions, you have to use the common sense and solve the answer. Okay, just assume there is a runway and there is a gate has to be kept after runway. Fine. So this is how you solve these questions. And another type of question that can be asked from airport would be radius of taxiway. Fine. So taxiway is the one which connects two runways, or it connects a runway with the hangars. Okay. So if let us say there is one runway and there is another runway, or there is a hangar. So taxiway is the one that connects runway with the aprons or hangars, everything. Taxiway, that means the aircraft will be moving here. That is the meaning of it. Aircraft will be moving here. Aircraft would be walking. It is a taxi thing. Fine. Aircraft would be moving something like this. This is called taxiway. Taxiway. Fine. So the radius of taxiway can be your question. So radius of taxiway would be equals to radius of taxiway equals to maximum of, it is generally given as maximum of v square upon 125 f. F value is given as 0.13 and we are not considering any super elevation over here. V is the speed in kilometers per hour. Same, v square upon 127 e plus f you will consider, but anyway here you will be considering this only. Or it can be taken as 0.388 w square upon t by 2 minus s. Fine. What is this, sir? See, if at all, if you take a pavement, then if let us say this is main gear and this is noise gear, this is main gear and and this is called as noise gear. Noise gear. Noise gear. So this length is generally taken as L. This length is generally taken as L or W. Length of landing gear. Okay, like in cars we have taken that as 6 meters. The same thing, that is W over here. And T is the thickness of the pavement, or sorry, width of the pavement, not thickness. T is the width of the pavement. Fine. And then S would be this distance. S would be from the center of main gear to the edge of the pavement. This is S. Fine. So if this is S, and generally this distance would be 6 meters. Generally this distance would be 6 meters. So S would be generally given as S plus, this is thread of wheel, or which is also called as thread of main gear. Thread of main gear. Thread of main gear. So that equals 6 plus thread of main gear. Thread of main gear. Thread of main gear. Main gear upon 2. That is the value of S. Fine. This is the value of S. That is center from the main gear to the edge of the pavement. T is the width of the pavement. T equals to width of the pavement. T equals to width of the pavement. W indirectly equals to length of the aircraft. Length of the aircraft. So that is distance between the axles. This is called main gear, this is called noise gear, or distance between the gears. That also you can say as W. Fine. So 0.388 W square upon T by 2 minus S. And if it is for subsonic jet, this is equals to 120 meters, and for supersonic jet, it is equals to 180 meters. 180 meters. So maximum of all these things would be your radius of taxiway. You have to remember this, and based on that apply, you will get your answers. Fine. So these are the major things that I have discussed. Why? Because this is what is asked in the examination. That's why I am discussing it here. If you want in depth, there were previous videos you can see, but I don't think so it is important over here. And so now with this transportation, I am completing the transportation with this. I have discussed some decent things. So I think from these 2 days, hopefully you get somewhere around 4 to 6 marks by God's grace. If you are lucky, you can score 100% of marks, provided if you are able to remember everything and solve everything. Fine. With this, I am closing the session, and thanks for being with me for 2 days. And Atul, you are there from morning. Thanks for being there. Soumya, you were there for 2 days. Thanks for being there. And hydrology, I don't know about. If you want me to take hydrology, I don't know about it. I'll ask and I'll let you know. If there is a link, I'll provide you the link, and you can come maybe tomorrow or day after tomorrow. If they give me the clearance today, you'll be getting the link tomorrow. If not, whenever the link comes, you'll get the link. I'll try for hydrology. If not, the other subjects. Okay. So yeah, thanks for being there, and all the best for your GATE examination. Bye. And please do like, share, subscribe, and if you want to say something, you can say. If you want to ask something, you can ask. From transportation regarding or anything regarding to GATE, you can ask. Anything you want to say, you can ask. At least now you are not ready to comment. Fine. I'll close the class. I'll close the session. Um, and if you're having any doubts, you can always contact me at this number. You can WhatsApp me at this number. Fine. So quick revision of transportation is also done. Fine. Maths, apt, GTE, TEE, hydrology, irrigation, CM, FM, these subjects only I prepared, sir. I neglect FM, RCC, steel and surveying also. Okay, steel is there. My videos of steel is already there. Instead of going for quick revision, there were some 10 to 12 videos of 2 hours classes were there. You can go through that. That would be helpful. And RCC, I think if you're not comfortable in Hindi, I don't know. Amit sir is taking in Gate Academy CEME channel. You can go and see over there. If not, I'll ask him. If he gives me the chance, I'll see that. Surveying, okay, I'll see if I can take a quick revision of surveying or not. Okay, I'll try to see. FM, I don't think so. It will be given to me. Fine. I'll try to see the maximum subjects I would try to cover. I'll cover it. Okay. And I hope transportation engineering quick revision is helpful for you. Okay, bye bye.